laptop volume alone, laptop speakers alone, definitely that won't be sufficient. So please use a headset. Ordinary mobile headset is just enough, right? So please use a headset. That will be much better. Okay, guys. So yesterday I've learned a lot of things in the measure phase, right? So today we are going to learn something very important: the statistical process control. See, actually, we have been working in this improve and control phase. We have been working a lot in the improve and control phase, right? So in the improve phase and control phase, we'll be learning a lot of tools. So what are the main objectives of the improve phase? See, in the improve phase, we have to implement a control measure. In the improve phase, you have to implement a control measure, okay, so that the root cause doesn't comes to the surface. What doesn't come to the surface, guys? The root cause doesn't come to the surface. Okay, that is the important point which you must remember. See, guys, we need to remember where we are using the particular tools. Okay, somebody else has, yes. Okay, so other things are as common documentation and transferring the process. These are the part of the control phases. But the important thing which you must remember in the improve phase, our main objective, our main job task is limited to implementing the control measures for keeping the root cause under control. Okay. So to do that, you need to monitor the process. You need to monitor the process after the solution was implemented. Okay. Guys, do you get it? Do you get it? Why we are monitoring the process? We want to monitor the process so that the root cause doesn't occur in another way, in another format, in another vision. Okay, in another kind of features. We doesn't want that to happen. So we want to monitor the process and find out if there is any deviation or fluctuation happening in our process. Deviation means variation beyond the control limits, variation beyond the acceptable limits. That is considered as control deviation. So when that happens, you need to be aware of it. For that, you need to keep on monitoring the process. Okay, you need to keep on monitoring the process. So just a moment. Okay, so in that case, there is a control plan. In the control plan, many activities are there, but statistical process control. The process is being monitored and controlled using a statistics. That is why we call it as statistical process control. See, we are collecting data from the process, right? All of us used to collect data from the process regularly. But how we are using the data, how we are interpreting the data and using it for the improvement of the process is very important. See here, we are going to convert the data into some statistical features like mean, median, mode, standard deviation, skewness, kurtosis, and other things. And we are going to find out whether our process is in line, whether our process is in sync with the existing requirement. That is what we are going to do in the control phase. That is an important part of the control phase. Guys, are we clear why we are going, what we are doing in the control phase? Okay. So other things are common which you have learned already. Okay. So in this, we are going to learn what is a control charts and the types of control charts, and we are going to learn how to plot the X bar, that is range and average chart manually as well as using Minitab. I believe all of you guys must have Minitab installed in your laptop and kept it ready. Are you guys ready, guys?
Yes, sir.
Are we ready? Yes. Okay. In the meantime, also you can keep some a paper, a pen, and a calculator handy because we are going to work out some manual calculations also. Because when you are going to work on a control chart in a Minitab, you should know how it will work on the background. What is happening on the background? What are the formulas that are running on the background to generate this chart? Okay, so then only if anybody is making the control charts, we are creating the control chart manually, you'll be able to find out that also in Excel sheets. Okay. So what is the purpose of the control chart? The control chart will help you to monitor the stability of the process. What does mean by stability, guys? What does mean by stability? Nobody knows what does mean by stability. Come on. Stability of
Consistency in the
process.
result.
Yes, consistency in the outcome, output, response. Okay, that is the chance of error or failure happening is very minimal. For example, if I say the CPK value is 1.66, what does it mean? The chance of error happening in that process is 1 out of 15 lakh times. That is, out of 15 lakh times, the chance of error happening is only 1. So that means the process is highly stable and it is very predictable. Okay, highly stable and it is highly predictable and reliable. So in order to monitor whether your process is stable, that is whether it is without errors or not, has to be identified, monitored, and regularly observed. So that is the main purpose of this control chart, to monitor the stability of the process. So then already you have implemented a solution, right? You have implemented a solution in the process. Why you have implemented the solution? There was already a problem, and the problem was considered as a Six Sigma problem. And in order to eliminate that, which was the problem was affecting your process heavily, increasing the defects or increasing the customer dissatisfaction. Okay, and it is affecting your stability of a process. Your outcome is not consistent. Your process is purely out of control, and the delta y, that is the variation, seems to be more. So after that, you have in order to control that problem, you have implement find out the causes and implemented the solution. But whether the solution is giving you the expected results, we want to demonstrate that, we want to prove that, we want to prove that the solution is giving an improved performance, that is a more better performance than the phase where the problem was existing. See, that was a goal statement in the project charter, right? In the project charter, we have written a goal statement, that is, current problem was we have this much percentage of defects or this much percentage of customer satisfaction. We want to improvise that. So we need to demonstrate regularly that the solution has improved the performance of the process. So for demonstrating that, for proving that, we need the control charts. Because before the solution was implemented, the control charts will be having many fluctuations, variations above the control limit. After implementing the solutions, we would have proved, we could demonstrate, we could prove that the uh, process parameters are well within the control limits only. We want to prove that. For that purpose also, we can use a control chart. Once your process is stable, once your process is highly reliable and predictable, you can inform the top management. You can be ready for the improvement of the process. What does it mean actually? That is, you can increase this, you can go for expansion, you can go for productivity increase, you can go for cycle time reduction, you can go for manpower addition, you can go for line expansion, you can go for technology enhancements. All these improvements can be done if the process is stable. That can be identified through control charts. So control charts is one of the important things which you must, important tool which you have to regularly use after implementing the solution, so as to monitor the stability and ensure that the process is providing a better performance than the earlier stage, and announcing that your process is ready for any improvisation in process parameters or in kind of infrastructure development. Okay, so there are two types of variation, guys. Before going to that, you need to know the types of control charts. So in the control charts, actually, we are going to see variations. The control charts helps you to find out the variations. See, there are two types of variation. One is normal variation or common variation or natural variation. Another one is special variation or abnormal variation. See, the normal variation is a natural one which happens in any process. It will fluctuate within a particular limit. See, for example, if you take the human body temperature, it will fluctuate between 97 to 99. Okay, so that variation is allowed. It won't affect the output or the process or the outcome or the cost. So that variation is always present in all process. So in our process also, we could have that variations. There is no wrong in that. That variation is called a common cause variation or natural variation. But for example, if the body temperature goes beyond 100 degrees centigrade or 100, then obviously it will create a problem in the body, right? It is unstable. It will create instability in our health. So that is considered as a special cause variation or abnormal variation. So we need to find out what is the reason for that variation. What is the reason for that instability? What is the reason for that abnormal variation? That is the next scenario. But that this control chart will help you to identify there is a abnormal variation, there is a special variation which is happening in the process. It is just a monitoring tool. It won't give you the reasons. You can go ahead and track the reasons once you find out. Okay, if you know there is some problem happening in the process in this particular shift or in this particular machinery or in this or in the particular work plan, we could track back and find out the reasons. So in the control chart, these two variations help you to predict whether the process is stable or abnormal. So please remember common variation, common cause variation, and special cause or abnormal cause variations. So what is a common cause variation? See, for example, what is a common and abnormal cause variation? Silisa. So nobody is online, huh? Everybody is on the flight mode. Only Santosh is available on the. Okay, Muralidharan is available. Okay. Okay, how much time normally does it take for you to go from office to home, Muralidharan?
15 minutes.
15 or 50?
One five. It's nearby.
15. Okay, nearby. Okay, so you are quite fortunate. Okay, so let us say every day it may be plus or minus 2-3 minutes, right?
Yeah,
Average.
correct.
Okay, so sometimes you may be reaching office in 12 minutes, sometimes it may be 18 minutes. Okay, so as long as the time is within 12 to 18 minutes, it's considered as a common cause variation. Okay, suppose if it go one day, if it takes 30 minutes, he has informed his family member that he has started from the office, but it took nearly 35 minutes for him to reach the home. Then obviously, your family members,
Some voice.
okay, so please mute yourself. So obviously, your family members will inquire you. Why? What happened? Normally, it will take only 15 to 20, 18 minutes. Why you have taken so much time? So he has to give a proper explanation. Okay, something happened, some traffic issue, some heavy rain. Okay, some political obstruction, some VIP crossing. See, whenever you cross that upper and lower control limits, definitely there will be a query about the reason for that. So here also, uh, a person was going from office to home in 39 to 42 minutes, 38 to 42 minutes. But here you can see one day he travels in 25 minutes, reaches home in 25 minutes. And another day he took 55 minutes. Another day it took nearly 1 hour 40 minutes. So here what are the common causes of variation? What are the abnormal variations here? Guys, you
Sir,
have to say.
regularly he's coming in from 38 to 40 minutes is a common cause. Wherever
Okay,
it's taken 25 minutes, 55 minutes, 1 hour, it's a special cause.
Special cause.
special cause, right? It's a special cause. Because of some reasons, the special cause, the time has extended beyond the limits. So if we are aware about the special cause reasons, then the problem can be rectified. But imagine in your process, if you are unable to identify the reason for the special causes or abnormal causes, then you have to initiate a Six Sigma project to find out and resolve that. That is the scenario here. So whenever you are whenever you are able to find out the reasons or the causes for the special causes, you are well and good. That's fortunate. You can resolve it. But if you are unable to find out the reasons, if you are unable to find out the reasons for the frequent fluctuation or frequent occurrence of the special causes, frequent occurrence of the abnormal causes, then you have to do a Six Sigma project. Are we clear with it, guys? Please give me a yes or no.
Yes.
Sir,
Okay.
here
Yes,
I'm
sir.
having one question, sir.
Yeah, please go ahead.
So normally in the special causes and all, we can easily identify through X bar at chat and all. So we can attack it, no? So to reduce the common cause is it required for Six Sigma or special cause already we are doing for QCC methodology and other methodology to identify the special cause and we can take actions and all. So why necessarily
Okay.
for Six Sigma?
Whenever you are not able to see the QQ8D or other QC tools are basic tools. You cannot resolve a chronic issue using those QC tools. See, we are using all these QC tools in different phases in the Six Sigma methodology in the training program itself. You see, they can give you answers, they can give you solutions to certain limit only. Beyond that, it will be difficult. Suppose if even after finding the cause using a Pareto chart or some other QC tools, if you still have the problem existing in your process, what will you do? You have to go for the next level, right? See, most of the tools which QC basic tool, most of the QC basic tools are conventional tools. It has been being used for many years, but they are uh, they have certain limitations. They cannot go beyond certain boundaries. So, in order to handle that boundaries and above only, we are going for the Six Sigma projects. See, when the problem is chronic, see, the special causes are occurring even after you implement certain basic QC tool solutions. Then what is your option? Okay, so the first and foremost rule for a Six Sigma project is it should be a chronic problem. It must be creating some disastrous outcome in your process to the customers, to the management output in terms of profit, money, turnover. Okay, then only you are going for this Six Sigma project. The problem must be chronic in the sense it has been existing for so many times. It has been frequently occurring, and you are even after implementing certain solutions, short-term solutions, it is not responding. In that case, only you are going for the Six Sigma project. Are we clear?
Yes, understood, sir.
Yeah, sometimes the reason may be the interaction of two phenomena. So in those
Yeah.
cases also it be helpful.
Yes, yes, very good. Actually, we are going to learn that interaction among variables in the DOE. So, black belt guys will be learning the interaction among two input variables, which can create a special cause in the DOE, design of experiments in the black belt last week. Okay, so you have different tools in Six Sigma methodology to attack the problem which is occurring for a long time, regularly, frequently. Okay, so but common QC tools and conventional tools, even 8D, they lack that kind of tools and that kind of in-depth to find out the reason for the special cause and implement a solutions. Okay, that is why we are going for it. Something in the chat. Okay, okay, guys. So this is not required. Okay, I need to show you the types of. Okay. So stability through which through which chart you can know the stability. Control charts will help you to find out the stability. So statistical process control. Please split the words. Your process control, okay, is going to be identified through statistics, statistical methods. So statistical methods are going to use to identify your process control. So if all the data if the data which you have collected from the process, if it is within the upper and lower control limits of the control charts, then you can find out that your process is stable. So control charts helps you to improve the stability of the process, helps you to find out the stability of the process. Okay, if you find that your process is highly stable, okay, that is all the whenever you develop a control chart, the data falls within the control limit only. In that case, you can think about improvising your process. That is called process improvement through statistical methods. Okay, that is statistical. Your data is going to be used to improve the process towards a uh, next level. So your capability of a process is going to be increased. That is, your process is going to be made a giraffe process from an elephant process. That is, your control limit lines are going to move towards the average center line, towards the center line. Okay, that is the next case. Okay, so just we are worried about this thing only. That is, the control chart is going to help you to observe the stability, monitor the stability of a process through statistical methods. Okay. So if your process is highly stable, you can think about improving the sigma level from 4 to 4.5, from 4.5 to 6, sorry, 4.5 to 5, like that. So for that, you can go for the statistical process improvement tools. Okay, now let us get into the hot topic which we have been assigned. See, these are the types of control charts. See, gentlemen, please remember the types of control charts. Yes, Sai Aditya, what is your question?
Sir, is Minitab mandatory or can I work on Excel as well?
See, actually, we are going to work on Minitab. Okay,
Okay.
Excel is just a manual tool, right? Minitab just generates a control charts in fraction of seconds. In
Okay.
Minitab, it is a Minitab. Can generate the control charts in fraction of seconds. If possible, you could install it in the meantime because it will take at least half an hour for us to get to the Minitab version. In the meantime, you can
Understood.
install it. So all of you
Okay,
guys,
sir.
my request is go ahead and install the Minitab because you need to have some hands-on practice in the Minitab. Then only you'll be able to find out the significance of Minitab and compare to Excel sheet. See, most of us are comfortable with the one which we are already using. But if you start using Minitab, okay, you would be really mesmerized because it can generate control charts in fraction of seconds. Okay, if you choose the correct options. So all of you just keep your Minitab ready in your laptops. In the meantime, also have a paper,
Sir,
pen, and
Minitab the
calculator.
free trial only, right,
Yes,
sir?
yes, free trial. It is valid for 15 days, I believe.
Okay.
So it will be difficult for you to install the Minitab in your office laptop. So please install in your personal laptops or desktop. That is quite a better
Yeah, it
option.
is valid for 30 days, sir.
Yes, 15 days. 15 days or 30 days. Okay.
30 days. Yeah.
Okay. So guys, please remember, based on the type of data only, we are going to we are going to choose the control charts. Okay, based on the type of data. Okay, already you are aware of this, right? Types of data, attribute data, that is this attribute data and variable data. Okay, what is this variable data? Continuous data. Attribute data is countable data. Okay, so just we are going to work on the variable data only. So how control charts are classified based on variable data? Today we are going to see the X bar R chart only. That is average and range chart. So listen, see, in every chart you need to plot data. So anyway, you are going to collect data from your process. It may be a banking sector, or it may be a hospital, or it may be a restaurant, or it may be a manufacturing unit, or a processing industry, or chemical industry, or food industry, or any kind of packing industry, or aviation industry, whatever it is. You are going to collect data. How you are going to collect data through inspection. Okay, you are going to, sometimes you may be inspecting every 1 hour, sometimes you may be inspecting every 6 hours, or during one shift, or you may be inspecting 10 out of 100 lots. So you may have different kinds of sampling technique. We used to call that as sampling. Okay, so you'll be following different sampling plans and different sampling techniques. Okay, so when you collect samples from the process for inspection, if the sample size is less than 8, if it is equal to 8 or less than 8, then you have to use X bar R chart. Are we guys clear? If the sample size, that is, you are going for inspection and collecting some data. Okay, so if the data collected, if you are inspecting only 8 number of samples per time in a single frequency, okay, then you have to use X bar R chart, that is average and range chart. If you collect more number of samples per inspection in a single shot, in a single visit, if you are inspecting more samples and collecting more data, for example, say you are checking 100 lots per day, okay, in a single shot. your team is checking 100 lots, then obviously it is X bar S chart. Suppose if you are checking 10, you are in a diagnostic laboratory, uh, they are taking tests for 100 patients every day. All of a sudden, the doctor visits and he checks 10 reports. So, which you have to use a X bar S chart. Okay, every day, 100 transaction, 200 transaction are happening in the bank. The manager audits immediately on of a sudden, as manager surprisingly audits nearly some 25 transactions, whether it is correct or wrong. Then you have to go for X bar S chart, that is average and standard deviation. Average and standard deviation. Okay, so depending upon the number of samples, you have to choose a type of variable chart. If it is the samples which you select in a single shot, in a single visit, in a single frequency, if it is more than 8, you have to go for X bar yes. If it is 8 or less than 8, you have to go for a X bar R chart. Are we clear, guys?
Yes.
Sir, here I have one question. Sir, in
Yes, sir.
every hour we are collecting 5 samples at a stretch. So like
Yeah.
with 25 subgroups we are having it. So that time we can go for X bar R chart, right?
Yes. The single frequency samples only matters. You are
Okay.
in a total it may be 25, but that doesn't
Yeah.
matter. So in a single frequency, if you are collecting 8 or less than 8, then obviously you have to go for X bar R chart.
Okay.
Okay, suppose if you are having only one sample, okay, then it is a individual moving range chart. Okay, similarly, if we are going for countable data, okay, if you are going for countable data, like defects, defectives, true, false, wrong, right, accepted, rejected, then you have to go for this type of data, attribute data. Okay, in that you have two types of charts. One is defects, one is based on defects, and another one is based on defectives. Let me pull the pen. Okay, one is defects and another one is based on defectives. Okay, here you can see it is purely based on the measurable data, continuous data. Here we are going to decide the type of chart based on defects and defectives. Okay, so here how we are going to choose it. Further, we are classifying the charts. In defectives, sometimes if the sample which you choose is same all the time, that is just now only session that they are collecting 5 samples every time. Okay, suppose if you are going to select samples and write a report like reject or unaccepted, then it is a defective chart you have to choose. In that also, if you collect same number of samples every time, see for every 1 hour you are collecting samples and writing a report whether the sample is accepted or rejected. In that case, it will be considered as a defective chart because you are working on defectives. You are not working on errors or fault. You are working on defectives. That is, your job is to either accept or reject the lot or accept or reject that component. In that case, you have two options. That is, if you choose same number of samples every time, that is, you choose 5 only every 1 hour. You choose 10 only every shift. You keep it same for all the time. Then you have to go for a fixed sample size chart. That is NP chart. That is NP chart. Suppose every time your sample varies, your sample number varies. Okay, 9 o'clock you are inspecting, collecting 10. 10 o'clock, so 9 o'clock you are inspecting 10. 10 o'clock you are inspecting 15. 11 o'clock you are inspecting 12. So that is a variable sample size defective chart. In that case, you have to go for a P chart. Okay, so for a variable chart, the control chart upper and lower control limit also will be varying. Okay, you can find that in the control charts when you plot it. Okay, similarly, for the defect chart, what is a defect? Defect is a error or a fault or a variation or a fluctuation or some kind of spelling mistake in data. Okay, in a desktop letter, something like that. So in that case, also you have two types of charts based on classification of the number of samples. The sample which you collect every frequency is same, then you have to go for a C chart. If the sample which you collect differs every time, then you have to go for a U chart. This is how the control charts are classified based on the type of data and based on the number of frequency samples which you collect every time. Are we guys clear about the types of control charts?
So please explain about fixed sample size and variable sample size, please.
For example, let us say there was a huge hospital, right? In the hospital, there was a diagnostic laboratory. So every day, hundreds of blood tests are carried out. Okay, hundreds of blood tests are carried out. So there is an audit which is going to be conducted every day. Suppose the number of audit depends upon the number of tests. For today, there may be 50 tests will be conducted. So normally the doctors will take 5%. So in that case, normally doctors may take 5%. It may be the rule there. So today he will inspect 5. Okay, tomorrow there may be 70 tests. So he may be doing 7 audits. Day after tomorrow, 80. So he may be doing 8. Another day it will be only 45. So he'll be doing 5 or 4.
That is a variable.
So this is so actually I am speaking about accepting the chart. See, if you go into the type of data and decide the control charts, that is a different thing. If you are going to choose the report or reject the report, then you can go for defective chart. Whether the report is acceptable or rejected, that is the case here.
Okay.
See, suppose if you are going into the patient's data, okay, about blood sugar level or calories or about platelet count or RBC count or white blood count or about this thyroid level, then it is going to be measurable data. Suppose if you are going to check the report and audit whether it is accepted or rejected. See, there are two types of audit. Whether the samples, whether you are going to audit the patient's data in variable data, that is a different category. Suppose if you are going to accept that test as accepted or rejected based on the skill set of the lab technician, whether he has done it correctly or not, that is what we are going to see. If he has done faulty, then we are going to reject it. That is a defective.
Okay, sir. Continue.
In that case, suppose if it varies, we have to go for a P chart. If it is same, we have to go for a NP chart.
Here, if you have a more number of defects, we are going for defectives. If you have one single number of defects, we are going for defects. That kind, right, sir?
No, actually, defect. What is it? I think you should know the difference between defect and defectives. See, defect is a. I will let me pull a chart for you. Then only you'll be able to. Because since you are having a gap of nearly 1 week and you are having a lot of work in between, you definitely will tend to forget it. There is no wrong in that. Okay, let me pull a slide for you so that you'll be able to know the difference between defect and defectives.
Yes, actually, that day you explained that if you have a chair, one chair, one side it is a broken and one other wheel broken and damaged or all the kinds of that, it is a defective. So we cannot use that. We cannot use that chair. So that is defective. That's what I think we have learned earlier.
See,
If you have one
when
single
the defect is critical, when the defect is too critical, okay, it makes that particular product or process or service defective. But okay, but remember, all defects cannot make the particular product defective. All products cannot make the particular product defective. So, for example, I have a slide which is displayed, right? I have a slide which is displayed in the, for example, instead of control charts, I have missed this L. See, I have missed this L. So, you people will be having some difficulty selecting control charts. You'll be asking, sir, what is that control charts? Oh, then I will say, okay, I have missed a L. See, this is not such a crucial defect, right? So these kinds of defects can regularly arise. Suppose if the fluctuation is happening, the error is happening, a fault is happening, which is not influential enough to make that particular product or service unusable. See, for example, take a pen. The pen may be having so many components. Suppose if there is a scratch on the body, if there is a crack on the body, scratch on the body, scrap on the body, uh, crack on the body, or a scratch on the handle. Suppose the handle is broken, but still the pen could do its intended purpose. Still, the pen could satisfy its intended purpose of writing.
Writing.
Until and unless the nib of the pen, the tip of the pen is broken, it becomes a then it becomes a defective, right?
Yes, understood. That I can understand.
Okay, so we have to differentiate between defect and defective, guys. Defectives is the product is particularly completely scrapped. See, in Six Sigma, we are more concerned about defects because defect occurs in the initial stage. If the defect keeps on regularly occurring, then it will lead to defect. Okay. So, for example, if a person is having a headache, that is a defect. If he allows the headache to happen and the headache persists regularly, then obviously it may lead to some kind of heavy chronic disease. Then it will be a defective. Okay. Similarly, suppose if there is a problem in the car, a small initial problem, it may be a defect. So, and that person, if you are not uh, listen, if you are not making it correct, if you are not repairing it immediately, it may become a, it may make the car unusable one day. It may completely bring the car to a breakdown situation. So then it became a defective, right? So we have to be very careful with defects in the initial stage. So sometimes if the error, fault, or deviation, variation, and any non-compliance which is reworkable, which can be reworked and corrected, is considered as defects. Okay. Suppose if the component is completely should be rejected because of a defect, and if it is unusable, then it becomes a defect. So for that also you have the charts. Suppose if you are in certain companies, they may be finding out the number of, they may be working on defects and defectives. So for them it will be easy for them. Suppose if you are going to find out what is the reason for the defect, then you may be going for a continuous chart. Guys, you got it? Initially, you'll be going for the defect and defectives chart only. Then if you want to find out what is the reason for the defects, then you have to go for a measurable chart. So all these charts can be used in a single process itself. Okay. So if the samples which you collect for defects, if it is same, if it is fixed, if it is equal all the times, see, if it is unequal, if it is varying, if it is fluctuating, you chart. Similarly, defectives, rejections. Okay, then you have to go for the NP chart and P chart. Any other questions, guys? Any other questions, guys? Are we clear? Okay.
Yes, sir.
Now let us. Okay. So this is how the control chart works. So regarding the control chart, I just want you to show how a control chart will look like. This is how a control chart will look like, guys. So this is actually an X bar chart. Actually, X bar R chart means you are going to draw two charts. You are going to develop two charts. One is an average chart. One is a range chart. Okay, one is the average chart, another one is a range chart. So what you are seeing on the screen is the average chart. Here you can see it is a graph, guys. Don't think control charts is something different. It is just a graph which you might have done in your lower schools or in your colleges in 10th, 11th, 12th, and college degrees. Okay, so you can see x-axis is there, y-axis is there. In the x-axis, you will be having the number of samples. Y-axis, you will be having the average of the samples. Then you'll be having a central line, average line, and you'll be having upper control limit and lower control limit. So our job here is to calculate the central line, average line, and the upper control and lower control limit. So this can be done manually using simple calculations, or can be used Excel sheet, and we can use Minitab. But we are going to see how to do it manually and Minitab only. Okay. So what we require for developing a control chart? For developing a control chart, we need data and the samples. The samples is called a subgroup here. The other name for sample is called subgroup. Sometimes we may say it as number of samples. Sometimes we may say it as number of subgroups. Okay, these are subgroup size. The subgroup size or the sample size. If it is less than 8 or 8, then go for average and range chart. In that case, the formula for calculating the central line is X double bar. That is average of averages And this is how you calculate the upper and lower control limits for a X bar chart and a R chart. For a X bar chart, it is X double bar plus A2 into R. A2 is a constant. For a lower control limit, it is X bar minus A2 onto R. So similarly for a R chart, it is D4 into R bar and lower control limit is D3 into R bar. The thing is here, this D4, A2, D3 and all constant, and this formula also you don't have to memorize. Just for your knowledge only, I am showing all these things. And just for your knowledge only, we are going to do it manually. Okay, so you don't have to worry about it too much because in many tabs you'll be doing these things just in a quick time. So you don't have to worry about it. Okay, guys. Okay, so now let us move to the control chart. So the X bar chart, we are going to monitor the process. Okay. So the X bar chart actually monitors the process mean and the R chart process variability. Okay, spread of the data within the particular samples. Okay, so whenever we have the subgroup size or the sample size less than 8, we are going to use the X bar R chart. Okay, now let us take a small example. Okay, so this is the example which we are going to use to draw the X bar R chart. So there was a quality team. Okay, so data was collected from a quality team to assess the consistency in performance. So a quality team is collecting data to assess the performance and consistency of four different work groups. So the process time of operations of the groups were collected. Okay, the process time of the operations. For example, um, every shift, a company may be having 4 shifts. Let us assume the company is having 4 shifts. So every shift, 250 people are working, or every shift there is 50 people are working. Let us say 50 people are working. So we are going to take samples. So from how many people we are going to collect only 5 number of samples. We are going to collect only 5 number of samples. So the quality team collects 5 number of samples from every work group. First shift, second shift, third shift, and fourth shift. Okay. So what is the subgroup size here, guys? What is the subgroup size?
4,
5, sir. 5, 5.
5.
5. So in this case, what chart we have to choose?
X bar
X
R
bar
chart.
R chart.
Yes, X bar R chart. Very simple. Okay. So now every day the team collects for every shift the quality team collects 5 samples. Similarly, they do it for all the 4 shifts. So totally every day they have in 24 hours or in a day they have 20 samples. Like that they are doing it for 5 days. So why they are doing to assess the performance, whether they are performing as per the expectations, whether they are performing within the limits, or whether the performance is worse or better. That is how this quality team is going to use control charts to assess the performance. So this is the data which they collected in the 4 shifts. Okay. So this may be the dimensions of the particular product, okay, which was made by the particular workers. So in this case, we are collecting the data from the process to assess the performance of the workers. So if the product which they are manufacturing is within the particular limit, we can say they are performing well. If it is not within the limit, then we have to find out what is the reason. This is why we are doing this control chart test. Okay, so I will go to this slide. This is same as the previous slide, but I have more content here in a single slide. Okay, so the subgroup or the sampling size is 5. The sample size or the subgroup size is 5. Okay, how many times? What is the frequency of sample? 5 per shift. Per shift, they are collecting 5 samples and they are collecting 4
shifts.
they are doing it for 4 shifts. So totally 20 samples and they are doing it for 5 days. So totally they got nearly 100 samples. So don't confuse the total number of samples with the sample size. Generally, it is a common error done by all people. So they will consider this total sample as the sample size. So they will go for X bar S. That is actually quite a wrong decision. So always look at the sample size. Okay, so first you have to compute X bar, that is average of the data, then range of the data, then average of averages, then average of the range, then you have to calculate the control limits. Okay, we will do it. So this is the data. So I believe each one of you can do some calculations, right? So what
Yes.
is the average for the first shift data? Add all the 5 and divide it by, okay, and already it is given. Okay, add all the 5 and divide it by 5. Give it for second. Somebody try and give it for second and third, fourth, fifth. What is the average for the second shift? And what is the range? Range is the difference between the upper and lower limits, guys. Sorry, higher and lower data. The difference between this higher and lower, 598 minus 601.6 is the range. So what is the value here, guys?
598.4 plus 599 is equal to divided by
599.76.
599.76. 599.76. What is the range here, guys? What is the highest value here? Highest value is
2.8.
601 to 4.8, right?
2.8.
It's 2.8.
Okay.
2.8.
Sorry, 2.8. So this is how you have to calculate for all the data for X bar and R. See guys, here it is average. That is why we have marked as X bar. But here that is just a difference between the highest and the lowest value in the sample. So it is just R. Don't put R bar here. Are we clear, guys? Are we clear? So you have to calculate the average for all the 20 samples, and you have to calculate the difference between the highest and lowest value in the sample for all the 20 samples. Okay, so once you have done that, this is it. Okay, once you have done that, okay, you can calculate the average of averages. See, this is the average. Already this is the average. So we have 20 averages, which you have done it from 20 day samples, 20 time samples. Okay. Then you calculate the average of the average, it becomes X double bar. Got it? See, guys, please listen. Let me repeat it once again. See, this is already the average, but this is not the average. This is the R. This is the range difference between the highest and lowest value in the particular sample. So we are going to add all these 20 averages and divide it by 20. Then we will get the average of averages. That is why we call it as X double bar. Here we are having only the range. So what we are going to do is we are adding all the 20 ranges and we are dividing it by 20. And then it is called R bar. Are we clear, guys, how to calculate X bar, R bar, and X double bar? Are we clear? Give me a yes, no.
Yes, yes, sir. Yes, sir. Yes.
Yes, sir.
Yes,
Okay.
sir.
Sir, please repeat R and R bar.
Okay. See how we are calculating R. See, R is calculated by subtracting the highest and lowest value in the sample. What is, let us take first sample. The highest value in the sample is 601.6 and the lowest value is 598. So you subtract 601.6 minus 598. It is 3.6. Okay. That is clear now, right? Then,
Yes.
like that, you have to calculate for all the 20 samples. So this comes around 2.84, 2.8, 2.6 like that. Now you add, this is R. This is R. Okay. Now you add all this 20 and divide it by 20. Then it becomes a average of range. That is what we call it as X bar. Are we clear here? Yeah. Vishal, are you clear? Are you clear?
Yeah.
Okay. So now we have calculated the X bar, X double bar, R and R double bar. Now it's time for us to plot the chart. Before that, we have to calculate the upper and lower control limits. Okay.
Sir, for R,
So,
there is no double bar. Correct, no, sir?
R, there is no R double bar.
Only
See,
R bar.
why we are not calculating R double bar? Because there is no need. See, what we calculating here is R.
R.
But what we are calculating here is X bar. That is the
X bar.
average. That is
Yeah.
why we are getting X double bar.
Okay, understood.
Okay. So now it's time for us to calculate now we have calculated the center line. This is the center line for the control chart. See, in the chart, I have shown you on center line, right? See, this is the center line, right? So now we have calculated the X double bar and R bar. So that means we have calculated the median line, center line for the particular control charts. Now it's time for us to calculate the upper and lower control limit. Okay, there is a formula. We have already seen it, right? Upper for a X bar chart. But the chart is called as X bar chart and R chart, not X double bar chart. Okay. For X bar chart, the formula is D4 into R bar and the R chart, the control upper control limit is D4 into R bar and lower control limit is D3 into R bar. Then for X bar chart, the upper control limit formula is X double bar plus A2 into R bar. Don't worry, guys. You don't have to remember any of these things. This is just for your knowledge because you must know how these things are getting calculated, right? That is why we are doing it. So lower control limit is equal to X double bar minus A2 into R bar. So using this formula and substituting the constants, we are going to calculate the value. So listen, here we have already calculated the R bar. And you know, this is a constant table which is available in the internet and it differs based on the sample size. If the sample size is 6, it differs. The sample size is 7, it differs. The sample size is 8, it differs. It is a constant universal table which is available in the internet. So if you just type X bar R chart constants, you will be getting that in the internet. So it is a common table. So let us see what is the data for our sample. For our sample size, A2 is this much, D3 is this much, D4 is this much. So what is the formula for our R chart? Upper control limit is D4 into R bar. What is D4 value? 2.114. Okay.
So
What is
where do
D3?
we get this D4 and D3 values?
Sorry?
How do we get these D3 and D4 values?
So if you are in the laptop, you can just type, okay, you can just type constant values for X bar R chart. Here it is, right? So you can just type in the internet and you will get all the data here. It is a common data which is available in the internet. See, let me constants for X bar R chart. You type that in the internet, okay, you'll be getting it. Okay, you'll be getting the constants for X bar R chart for different sample size. So it is available in the internet. Okay, it is called control chart constants. It is called control chart constants. So it will give the sample sizes and the constants. Got it, guys?
Okay, sir.
So I can, if you want, I can get one table for you.
Yeah, please, you can show in the screen, sir, so that.
Yeah, I will get it. I will get it in the print screen. Where is the print screen? Yeah. Sorry. Okay, I get it. Just a moment. Here you can see I have taken a screenshot of the. Okay.
So what will be the input for this?
Just type
Sample
control.
size?
Just type control constant for control charts X bar R chart. Then obviously you will be getting that. If you type constant for.
Sir, but
The
for
input is
sample
sample
size
size or?
more than for sample size more than 8, we said we have to use the X bar S chart, no?
Yeah.
But in this again, the sample size they're giving values for 10, 9, and all.
Yes. When you use X bar S chart, you have to use these samples. This is the control chart constant values. This is
Okay.
this is a common control chart constants, right? It is common for control charts. Even see for the X bar S chart also, you have a similar constant. Here you can see X bar S chart. A2 into R bar, A2 minus A2 R bar. Here, yes. Got it?
For sample size unknown, like I mean, we don't know the sample size infinite. Then how do we do that, sir?
See, how do you have an infinite sample size, right? You always be having a finite sample size. When you are going to collect data, you will know how many data you are collecting per time, right?
Okay. No,
You
I
don't
was.
have,
Uh-huh.
you
Okay.
cannot collect infinite samples, right? How it
Okay.
is possible? Every time when you collect data, you know how many data you are, how many times you are going to do the inspection. See, for example, if you are doing a, let us take a food industry. Okay, yes, Vikas, I will come to Vikas later. Say food industry, there are packets being packed. So out of 100 bundles, they are collecting 10 bundles for checking. So sample size is 10. Similarly, you will be collecting samples in every industry. The sample size decides a constant value for the X bar R chart. Yes, Vikas, what is your question?
Yes, sir. To get the expert R chart, is it necessary to remember this constant values, or do we need to carry these values always? Will it
No,
be fed
no
into the
need.
Minitab?
No, everything is available in the Minitab, guys. You don't have to worry about these values. See, the thing why I am explaining you this is you must know how the Minitab works, what is happening on the background of the Minitab. Suppose if somebody is making a manual chart, you should be able to understand how they are doing it and you should be able to verify it. Okay. All charts, all the 7 control charts are working in the same fashion. We are just going to give you sample of one control chart only. X bar R, X bar S, IMR, N chart, P chart, C chart, U chart. All these charts are working in the same fashion. That is, an center line is calculated, that is average line, upper control limit, lower control limit, then the data is plotted. And the upper control and lower control limit lines are calculated using constants. The constant is decided based on the number of samples. Okay, sample size which you are choosing. So you may be doing 10 inspections every day. During every inspections, you may be collecting 3, 4, 5, 8, 10. That sample size decides a type of chart and decides a constant value also. The constant value is available in the internet. I have taken this and pasted from the internet only, guys.
Yeah,
Okay.
this will be useful,
So,
sir.
okay. So if you just type common constants for control charts, you will get it. This is a common value only. It won't change. Anybody can get it. Are we clear, guys?
Yes, sir. But if
Yes,
sample
sir.
size it is given only up to 10,
Hmm.
if required, we can get for more.
Yes. Yes, you can get it for more also, no problem.
Okay, okay. But it should be a continuous.
Yes. This is for continuous data only.
Continuous data. Okay.
Okay. Okay. So now you have the constant values and the formulas, and you have already calculated the R bar, X double bar also. So now our job is to substitute and find out the value. Okay. So this is what we have done. Okay. So now this is a formula for the R bar chart. The R chart. Guys, remember one thing. I don't have the pen. Where is the pen? See, when you are plotting the X bar R chart, first you have to plot the R chart. Please remember, first you have to plot the R chart only. If the R chart is showing you fluctuations, is showing you variations above the upper and lower control limits, stop there itself. No need to go for the X bar chart. It is a waste of time. Because if R chart itself is showing variation, then obviously X bar chart also will have more variations. Got it, guys? Are we clear?
Yes, sir.
Okay.
Yes, sir.
So please remember, if there is a variation in the R chart, stop there. Because X bar chart is definitely is going to have a variation. So that itself is an indication that the process is out of control. Okay. So now let us plot the R chart, range chart. So these are the range values which we have already. These are the range values which we have calculated, right? From the samples. These are the range values. And this is the R bar value which you have calculated. And you have calculated the upper and lower control limits. Okay, using that formula D4 into R bar, D3 into R bar, and you have the D4, D3 value taken from the internet common constant control charts. Okay, now what is the first data? What is the first R value?
3.6.
Meter on the first day, first shift, 3.6. So this is a control central line R bar. This is the upper control limit, lower control limit. Here you can see the D3 value is 0. That is why we have the lower control limit value was 0. Since D3 value here is 0, okay, lower control limit line is 0. Okay. So let us plot the first point, 3.6. So 3.6 is the first sample range, 3.2.84. You keep on plotting all the points one by one. Now we have plotted the R value of 20 samples in the range chart. Connect all this. Whether it is within the upper and lower control limit, guys.
Yes, sir.
Within the
So
control.
within the control limit. So as far as the range chart is considered, the process is well within the control. So you can be happy about it, and your process is well within the control in the range chart. Okay,
Sir, even if one data point is out of the lower control or upper control lines, then we need to stop it.
I will come to that point later. Yeah, that is a discussion which we are going to have after this chart only. Okay, I will come to it. Okay, so now please just wait for another 5 minutes. Okay. Okay, so now this is a range chart. So range chart seems to be perfectly right. Now let us go for the X bar chart. What is how to do the X bar chart? You have to calculate the central X double bar line. That is already we have done it. That is 600.02 upper control limit, lower control limit using this formula. Okay, A2 and A2 is already taken from the constant table. Okay, so upper control limit, lower control limit is done. And we have calculated the value. X double bar is there, upper control limit is there, lower control limit is there. What is the first X bar value from sample 1?
600.36.
Second one is 599. You keep on plotting all the points. Okay, now how does the X bar chart look like, guys?
One data
One
point is out of
outlier.
the
Only one
LCL.
data point.
Which data point and which particular sample can you predict it? Can you identify it?
Ninth data point.
Ninth data point. So on which shift, on which day?
That we have to.
Yes. Yes, guys, come on.
Which day?
It's average only, no? So we have to go for the individual data. Then only we can understand.
Yeah, actually, you have to go for the individual sample. On which sample it was?
Third day
Yes, you
first
have
shift.
to predict. Third day first shift, whether it is 8th or 9th. It is the 8th data, right? It is the 8th data. That means it is the second day last shift. Correct, guys? So actually, one starts here only. See, this is one, but it starts here only. So this is 8th.
8th data, 598.24.
So on the second day, 8th sample collected seems to have variation, fluctuation beyond the control limits. So what we have to do is we have to first do an investigation. That fluctuation in this control chart indicate the variation in the process is above the allotted limit. So it may be due to special cause or common cause. If it is due to a common cause, then it is allowed because it will come back to its original position naturally. Okay, if it's because of a common cause, it may be due to you don't have to worry about it, but you have to verify that. The common causes of fluctuations in X bar chart may be different suppliers. You might have purchased raw material from a different supplier. Okay, or you might have inconsistent material quality. When you may find that in the material testing chart, or there might be a change in the material composition. For example, I'm saying in a steel rolling mill, the variations in carbon content. Okay, maybe because of that, or On the day, the particular employee may be, in this case, the particular employee may be sick. So it is a known common cause. So because of that, he has not performed well. Okay, so then there is nothing to worry about. Because next time you could have, suppose if the data which was collected, you have to, but remember, you have to make a thorough inquiry. That is the thing. See, you are observing it. See, these are all 5 days data which are simply plotted in a graph, and you are able to find out the reason and monitor the reason easily. So here you can see this day, 8th shift on second, 4th shift on last shift on second day is having a problem. So what you have to do is, first you have to find out who is the data collector, how was the data collected, okay, what is the frequency, when they collected the data, which shop floor it was collected. Everything has to be investigated and inquired first. First you have to ensure that the data was without errors. What you have to ensure that the data collected was without errors. If all these things are clear, then you have to check where is the problem. Suppose if the data collector says, if you inquire the data collector, he might say, "Sir, on the day I was sick, so I didn't go to the shop floor. I wrote the data I wrote the data without going to the shop floor. I have written it mine itself. I have fabricated the data." Then obviously that is solved. So you could warn them and say, you should not do this. Okay, do it properly. Problem clear. Normal cause of fluctuations. But when everything is correct, everything seems to be done properly, but still you have that variation. And what you have to do is you have to regularly monitor the process. After that, you have to regularly monitor the process. If it happens again in the next 5 days, it may happen 2-3 times. And if it happens regularly, if it keeps on increasing, then, and if you are unable to identify the cause, okay, then you have to worry about it, because the cause is not known. You are unable to find out the cause. You are unable to find out the reason. Then you need to go for a Six Sigma project. Or you can try with the simple tools earlier, like AD or whatever you have in your organization process following. You can try with it. If it is resolved, well and good. But still, if it occurs chronically for 2 months, 3 months, 5 months, then think about you have to go for a Six Sigma project. Got it, guys? Any questions? Any questions, guys?
Yes.
Any questions? Yes.
Sir, if what happened for the special cause, if it is not traceable, like it happens only once, but it is weird, like the next few days it is not occurring. So if we do again try to like try
See,
to track
no
it
problem.
and
See, if it occurs only once, next time after, if you do it for every, see, for example, in a month, there are 30 days. Let us say it is 30 days month. So you keep on monitoring for the 30 days. It occurs only in the first week and it doesn't occur in the remaining 5 weeks. Then you can leave it. You don't have to worry about it because it is still a special cause, but it has not occurred. It might have occurred because of some kind of weather, some kind of unknown reasons, but it has not occurred. So your job is to monitor and find out whether it is occurring frequently. If it is occurring frequently only, then it is going to affect your output, right? See, what will happen on the day the employee performance was poor, so the lot will be getting rejected, guys. So the lot will be rejected by the quality team. Quality team has rejected the lot manufactured on that particular day shift. So if it happens only once in the month, on that month, for example, in the June month, it has occurred only once. So you doesn't have to worry. But if it occurred 2 times in the next week, 4 times in the another after that week, 5 times, then the number of lots rejected, the number of rejections are more. Then you have a cause to worry. And if you don't know the reason for the rejection, then obviously you have more worries. Yes, Sai, what is your question?
Sir,
that to start.
here we have not discussed about this R bar chart, no? That one is not there in this. In this only we are using X bar, X double
See,
bar chart.
yes, yes, R bar chart was quite clear. If R chart is having a problem, check what find out the same reasons. You have to go and find out the same thing. You have to do it. Same investigation inquiry. If, for example, let us say in R chart you have this problem, you go ahead and do the same inquiry and find out why it is there is a variation beyond that particular range. Do the same thing. You have to do the same for all the charts. The chart is just an indication of your process performance, whether it is within the limits or out of limits. If it is out of limits, just go ahead and find out the reason and try a remedial action. If it is happening again and again and again frequently. If it is not so, ensure that it happens, ensure that it doesn't happen. Okay. If it is happening and if the cause is not known, then the only option available is some kind of tool mechanism. Either you go for your own conventional tools. If that also doesn't helps you, then go for Six Sigma projects. See, all the control charts purpose is only one thing. Okay, to find out whether your process is producing rejections or whether the performance is within the limit which has been assigned by the process. If that goes beyond it, then you have to worry in the sense that you have to find out why it occurs. What is the reason behind it? If the reason is known, you could solve it, right? For example, whenever you go to a hospital, the doctor immediately asks you to take a number of tests. Why? Because you want to find out the reason behind that particular illness. See, if he knows the reason, what he will do, he will help you to die. He will help you to resolve it. He will help you to solve it by medicines. So, in our the diagnosis mainly because of the diagnosis is successful. The treatment is mainly successful because of the diagnosing methods only. Correct test has to be taken and interpretation has to be done properly. Same thing is done here also. This is like a medical field. So your process is sick or well, healthy. It is indicated by the control charts. If your process is healthy, everything will be within the limits. If your process is unhealthy, it will be having fluctuations beyond the limit. So go ahead and find out what is the reason. Take more tests, collect more data, regularly monitor it. And if the reason is known, do a corrective action. If the reason is not known, then we have a solution that is Six Sigma project. Got it, guys? Are we clear?
Yes, yes.
Okay, so this is how we execute a X bar R chart manually. Okay, so so this is a chart which was drawn using Minitab. This was a chart which was drawn using Minitab. Okay. So what we do is, guys, shall we go ahead with the Minitab now?
Yes, sir.
Sir, before that, I have a quick question.
Yeah.
Why
What's the
do
question?
we want to? Why do we want to go for two different graphs? Why can't we directly go for X double bar graph?
Why do you want to actually see? Here we have a sample. Okay. Here
Screen not coming.
screen. Is the screen coming, guys, or not coming?
No, sir,
On
your
the way.
screen is not visible.
Not visible.
Okay. I need to share it. This is the PowerPoint mode, I believe. I think it's the screen is shared now, right?
Yeah, it is on the way. It
It's
is.
totally black, sir.
Just hold
Has
on.
started screen sharing. That message is coming.
That is why I'm seeing.
Yeah, that message is coming, but the actual presentation is not there.
Whether you got it?
No, sir, not yet.
No, sir.
Yes, got it?
No.
No, sir.
It is happening, yeah. Okay, I will remove the. I think I have to share this one. I think now you got it, right?
No.
No, sir.
No, sir.
No.
Content is not visible.
Yeah, content is
It's black
only
screen.
only your name
It's a
and
black
a
screen
start
only. I can see
and
only black
double
screen.
click to enter full screen. That note is coming in the middle of the screen.
It's just processing.
Yeah.
See,
Sir, you're on mute.
So you need to unmute, sir. You are in mute.
okay, guys, I have been ousted out of Zoom. So the host has been allotted to somebody else. Who is Ponnusamy Chinnadurai? You got the host, man. So you have to change it to me.
Okay, sir. No problem, sir.
Please change it to me. And the participants, you go and find my name, Dr. Ravi Kumar. And on the right hand side, you have options to change host to me. Then only I can do the sharing thing.
Oh.
Or we can check after break.
Okay, in the meantime, I will go ahead and share it. Okay. Guys, it is okay. Are you able to see the screen now?
No, sir. Now it is visible.
Okay, in the meantime, I believe Ponnusamy will change the host to me. Ponnusamy, you will be finding 3 dots when you select my name on the right hand side. In that, you click and change to host. So,
You could see your screen now.
things. Ponnusamy, are you able to change it? You click. Please keep on trying. In the meantime, I will give you a reason why we are using. See, already I said about this. The X bar chart will help you to monitor the process average. Okay, I have posted it here.
You are the host now, sir.
Yeah, it is clear, so you can try now.
Thanks, man. Thanks a lot. Okay, great. See, the X bar chart, it helps to monitor the process mean, average of the samples. While the range, it monitors the process variability, the spread, the distribution of the data. Okay, so that is why we are using different charts. So both charts are needed. Okay, both these charts are needed. So the relationship is if the R chart is out of control and X bar limits are not reliable. Okay, so both of them look same. The outcome may look same, but remember, it is monitoring different parameters. Both of them are connected. Okay, so it looks into the average of the sample. It looks into the distribution, the variation in the sample. Okay, so X bar chart, it helps you to track the average of the process data sample, and this R, it helps you to find out the variation. So when this X bar R bar chart, if it is goes beyond the limit, then obviously the X bar limits also are not reliable. Okay. Then apart from that, only after the R bar chart is stable, X bar chart should be interpreted. If R bar chart is unstable, then there is no need to go for that. Okay.
Yes, sir. Thank you.
See, a process, there is a possibility that a process can fail in 2 ways. Either the average can change or the variations, that is the spread can change. Okay, so in order to monitor the process effectively, statistical process control, we are monitoring the process average and we are monitoring the process variation. We want both these things to be within control. That is why we are using a X bar R chart. So remember, R is for monitoring the process distribution, sample distribution. Distribution in the sense variation among the data, spread of the data, spread. And X bar is for mean of the process. So both these are connected. Okay, both of them together only can help you to monitor the process properly as per the statistical process control protocols and rules. Are we clear, guys?
Yes, sir. It's clear.
Okay, now let us go for this mini tab. Yeah, already mini tab open. Guys, you could also open mini tab. So now I am going to share my screen. Yeah. I believe you are seeing my screen. Guys, have you got this screen?
Yes, sir.
Okay, I am in the mini tab screen. Okay, I believe all of you have installed the mini tab. So in the mini tab, now we are going to plot the same data in the mini tab. Okay, there is an option called file on the left hand side top. Click on file. Okay, click on file. Open.
Worksheet.
Yes, open worksheet. Yes, have you clicked on that?
Yes, sir.
Yes, sir.
Now at the bottom, see at the bottom there is look in mini tab sample data folder. There is a option like that.
Correct.
All of you got it? Click on that. Just scroll down and you will find a link called camshaft MTW. Camshaft MTW.
One minute, sir. Camshaft.
MTW.
Only camshaft
Only,
two
only camshaft
Two.
and camshaft
is
2 are there.
available. Camshaft and
Only
camshaft 2.
click on camshaft MTW.
Camshaft
MTW
MTW not
is
there,
not
sir.
there, sir.
Okay. Only camshaft 2 is available.
Yeah, camshaft and camshaft 2.
Click on camshaft.
Okay.
You can double click on camshaft. Click on OK, it will display the data here.
Yeah, the copy of the content will be added in the current version.
Yes, click on OK.
Yeah, it is coming.
Just a moment, I will check.
Sorry, sir. For me, it's not opening that file. When I open file, I get a new project worksheet and report. When I open worksheet, I can see only the Excel kind of sheet opened below.
Explain from starting.
Is that clear?
What you are getting?
When I open the worksheet, then it open only in Excel kind of things. It's not opening like this session. These things are not coming for me.
These things are not coming for you.
Yeah.
Okay, then I will do one thing.
Yes.
I will copy paste the sample data paste as it is like in the okay, what I will do is I will copy and paste this
Okay, sir.
in an Excel sheet. Okay. And I will share it in the group. Okay. Okay, we will share it in the chat.
Yes, sir.
I think I have shared that data in the file. Copy paste as it is in the Minitab. Right? So those who are unable to do it, you can do it like this. You can. Okay. So guys, all of us got the Minitab, right? So click
Yes,
on
sir.
statistics. Click on statistics on the top.
1 minute, sir. Statistics.
It's a fourth tab, calculator.
Yeah.
Okay. On that, click control charts, the fifth one.
Control charts. Okay.
All of you just keep on following me. Okay. Then there is the option variable charts for subgroups.
Subgroup. Yes.
Yes. Click on X bar
X
R.
bar R chart. Okay.
Now you have this. So this will be empty. This will be empty. So you just click on that. All the columns will appear there.
Where to click?
You just click on
okay.
this.
Box. Okay.
All of you got it?
Yes.
All of
No,
you
sir.
guys.
Could you please repeat again?
Okay.
We did not get that.
Have you gone up? Have you got up to this, guys? Have you got up to this?
Yes, sir. That pop-up came in. All observations.
Click on OK.
Oh, okay.
Now you got this display, right?
Sir.
I will start.
Camshaft.
You'll be getting a window like this. Click on it. Okay. All of you got up to this?
Yes, sir.
Yes.
Click on statistics.
Control chart.
Control charts. Control charts are subgroups in the
X bar R bar.
Okay.
Yes.
There will be a click on this. Click on this column and click on this column. You will get all the data lengths of one and column C1, C2, C3.
Yes, sir. Yes, sir. We
can see that. Got it. Yeah.
Now click on the column C1 and click on this box, and you will get the length displayed here.
1 minute.
Click on this.
Where to get the length?
Click on this box. See the screen. Yes, click on this box. Then double click on length.
Yes, sir. Yes, sir.
Okay, 1 minute.
Yes, sir. We are getting.
What is the subgroup size here for our data?
100.
90.
Come on, yeah, that is the total sample size. What is the subgroup size?
3.
What is the actual subgroup size? There is the same example. Same data. 4. So it is 5, right? Have you forgotten it? Come on, yeah.
5.
It is the same sample, right? Same sample.
Oh, yes, 5. Okay, now we relate. Yeah.
So enter 5 here.
5.
Now there is a OK button at the bottom, right?
Yes.
Click on that. Have you got the graph?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is the same data. There is a small variation there. The same thing. Okay, here the X bar chart is having a variation on the 8th data sample. But it seems to be better. So if you do it, it will take only a bit of seconds, 30 seconds like that. But now you know how this chart is drawn. Okay, on the background, what are the data that is calculated? What was data needed? Everything has been clearly known to you. Right, guys? Are we clear here?
Yes, sir.
Sir,
Any questions?
one thing
Yeah.
regarding that data in the Excel sheet, in your presentation, it was clearly visible regarding the number of subgroups and the number of shifts and everything. Here, while putting the opening the statistics and the R bar chart, we only clicked on the length and the second and third column. What do they also stand for? Observations also?
Yes.
Because
Actually,
finally we clicked only.
It is the same data. Okay. Let me see. See, the data is actually how many data we have. 100 data. This data alone is taken for consideration. This length, this alone is taken for consideration.
Noted, sir.
Okay. This alone is taken for, this is the only data which we have collected.
Noted,
So this
sir.
is actually the highest value and the lowest value. This is the highest value in the data and this is the lowest value in the data. This is for taken for range.
Can you explain again how to draw the graph?
Graph. Okay. You click on statistics, click on control charts, click on variable charts or subgroups,
X bar R chart,
X bar R chart. Then
Length.
you'll be getting this. Double click on this box and double click on the length. Then the subgroup size you have to enter 5.
Okay.
Have you done up to this?
Yes.
Perfect. Now click on OK. You can make it large. You can take a screenshot or you can just copy. If you right click on that, there is an option to copy the graph. You can copy it and paste it in an Excel sheet, or you can paste it in a Word file. You can paste it in the PPT, and you can just, yes, Vikas, what is your question?
Sir, basically the subgroup is nothing but the number of samples that we consider.
Yeah,
this, right?
yes. Please remember, sample size, subgroup size, all these are same. Yes, no other questions means we can have a break and we can go for dinner, right?
So we will join by?
Yes, we will join back by, time is nearly 8:40. You will back by 8:50. You will come back by 8:55. Is it okay, guys? Okay, next we are going to see the cause and effect matrix. Everybody back, right?
Yes, sir.
Yes, sir.
Yes, sir.
You are able to see the screen, right?
Yes.
Okay, so what is the cause and effect matrix? See, in the analyze phase, we have an important role. We have an important task of finalizing the potential causes and critical cause, that is a root cause. So we are going to use this cause and effect matrix for finalizing the potential causes, or finalizing the potential cause, or even the critical cause or the root cause sometimes. So this cause and effect matrix is a structured decision-making tool which we are going to use in the analyze phase to find out the relationship strength between the causes and the effects. Okay, so actually causes and the problems, to be very specific. Actually, we have a problem and we have listed out the possible causes in the analyze phase. Okay, so using the cause and effect matrix, say this is a bit of quantitative tool. This is a bit of quantitative tool. So in the analyze phase, we are going to finalize, we are going to first list out the possible causes. Okay, guys, do you remember that? Do you remember the steps in the analyze phase?
Possible cause, yes. Probable cause, root cause.
Yes. So I will pull that first slide for you again. So here you can see first we have to list out the possible cause, then potential causes. Okay, so we are going to use this cause and effect matrix, okay, to list out the possible causes. To find the strength of connectivity. We are going to use this cause and effect matrix to find out the strength of connectivity between the possible causes and the problem. We have a problem in hand. What is the connectivity between the problem and the possible causes? So it is used in common tools also, quality tools also. So this cause and effect matrix helps us to understand which factors, that is, which causes have the greatest influence on the problem or the outcomes, or which factors have more influence on the problem and which needs more immediate attention or focus. We are going to do this in a systematic evaluation method. Okay, we are going to find out the connection between the cause and effects in a systematic evaluation methods. And apart from that, we are going to use a data-driven method only. Here, the data is collected and a small analytical method is used, and based on that only we are going to use it. Okay, and here also we are going to visualize in the matrix format. It is just going to be in the matrix format. That is why we have a term called cause and effect matrix. The causes and the effects are going to be connected using a matrix, and then we are going to get a output number. That number will help you to prioritize which cause is more potential and which cause needs more attention and which cause has great influence on the particular problem or in the process. Okay, guys, do you got it? That is what we are going to do in the cause and effect matrix. So this is how a cause and effect matrix is going to look it. Okay, we have a matrix structure. In the matrix structure, you are going to list out the causes and the outcomes. Okay, causes and the outcomes, process outcomes in the top side and the left hand side. So don't worry, I'm going to give an example so that you'll be able to understand all these things. The relationship is evaluated. The relationship between the causes and the inputs. Sorry, the relationship between the causes and the inputs. Okay, the relationship between the causes and the inputs are going to be generated in the form of a score. What scoring system we are going to use? If there is a good connectivity between the cause and the problem, cause and the effect, you are going to get a score of 9, strong relationship. If there is no relationship, you are going to get a score of 0. If there is a weak relationship, you are going to get a score of 1. If there is a moderate relationship, you are going to get a score of 3. Okay, so we are going to evaluate the cause connectivity between the causes and effects using a scoring system from 0 to 9. 0, no relationship, 9, strong relationship, 3, moderate relationship, and 1, weak relationship. So based on this scoring system, you are going to generate a score for the particular causes, and if the causes which is having a highest score is going to be prioritized for immediate attention, focus, and action. Okay. So now I am going to take an example. The example is what are the problem is the customer satisfaction. The customer satisfaction in the bank is very poor. Okay, the customer satisfaction in the bank is very poor. So the causes, so we are going to give score. Okay, we are going to give score. For customer satisfaction, it is 10, and for the service quality, it is 9, and for the transaction error, it is 8. So these are the importance important score which we are going for every important cause. Okay, see when it comes to a bank, okay, the customer satisfaction is an important cause which we must work, which we must give attention. Service quality is one important area which we must give attention, and transaction accuracy or transaction error is also one of the important area which we have to give attention. So the importance, the first importance is given to, see, this is the importance score. We call this the one which I have written in the red. Okay, is the important score for customer satisfaction. The bank is given top score for the customer satisfaction, and for service quality, it is giving 9. Okay, then for transaction accuracy or transaction error, it is giving 8. Okay, and the inputs. What are the inputs the bank is depending upon? Training. The employees are trained. Okay, in order to manage these causes. And the waiting time. The waiting time is also one of the important things the bank has to look into to improve this course. Then online banking system, staff availability, then security measures. Okay, so now what we are going to do is we are going to give scores for all these inputs. Okay, we are going to give score for all these inputs: the employee training, the waiting time, the online banking system, staff availability, and the security measures. Oh, so just listen. See, for example, the customer satisfaction is given 10. Why? because this is the most important outcome, as a satisfied customer is more likely to remain loyal and he will bring more customers to the bank in the futures. Okay, that is why an importance rating of 8 is given. So this is the effect. This is the effect. Okay, then service quality. See, the service quality should meet the customer expectations in terms of reliability, response, and professional approach. That is why we are given an importance rating of 9. And when it comes to transaction accuracy or error, the bank has to ensure that transactions are processed correctly without errors, maintaining the customer's faith, loyalty, trust, and the government regulatory complaints. Okay, so that is why we are giving this importance factors. Okay, so based like this here, you can also list out the effects or the input factors and the importance factors. The important factors has to be decided based on the team. Okay, why the customer satisfaction is given the highest rank here, highest importance score here, because it directly influences the bank reputation and profit. Oh, if the customers are not satisfied, then the bank will have less customers, and obviously the bank will have poor reputation, and obviously the profit, turnover, everything will take a hit. Okay, so that is why we are given customer satisfaction the most highest importance score. Okay, now let us come to the rows. Let us come to the employee training. See, the employee training, what does it refers to? The bank has to train the employees, okay, about the banking procedures, customer service skills, and the government requirements and the technology usage. Okay, so when it comes to the relationship score, a score of 9 was given for the employees training and the customer satisfaction. It indicates that properly trained employees will strongly influence the customer satisfaction, because they can handle the customer and solve the problems effectively and communicate them properly. That is why we are giving a score of 9 for for employee training when it compares to customer satisfaction. Got it, guys? So what we confirm is there was a strong relationship between the employee training and the customer satisfaction. Do you agree with me, guys? Yes, no?
Yes, sir.
Okay, so similarly, a score of 9 for a strong relationship exists between the service quality and the employee training, because if the training is not provided to the employees, it will affect their service quality. So training has strong relationship between the customer satisfaction. There was a strong relationship between the training and the customer satisfaction, service quality and the customer satisfaction. Okay, if the service quality was not good, then obviously customer satisfaction will be affected. So that is why a score of 9 was given. Then what about the transaction accuracy or transaction error? A score of moderate score was given. So it indicates that a moderate impact, because trained employees are less likely to make errors. See, if an employee is trained, then what about the transaction error happening? It will be less or more, guys. See, if you are trained well, what about the job which you are carrying out? You will be doing only less errors, right? So a transaction score of moderate is given, because training error will be less when the employee is trained good. When the employee is trained better.
Yeah, sorry, sir. The same thing applicable to customer satisfaction and service quality, because the training, if they do properly for the customer satisfaction, how to receive customer, how to transact with customer, and the service quality, how to do. So if that also addressed in the proper training, so
actually
just,
this is a negative cost. This transaction error is a negative cost. What is the influence of error on employee training? If the employee is not trained properly, there is no training, then obviously transaction will be error will be more. If the employee is trained, then the transaction error will be less. Okay. Either it should be 0, it should be 1 or moderate.
Yeah.
Be 1 or moderate. Normally, there is a possibility of error happening here and there. That is why we have given a moderate score. Okay. Then let us go for this waiting time. What about the waiting time? See, the waiting time, actually it is the amount of time the customers, the people who come there, spend in queue or in the are waiting for the service. Okay, that is what we refer it as waiting time. So here we are given customer satisfaction score of 9 and service quality of 9 and transaction accuracy of 1. So a score of 9 for customer satisfaction indicates that the shorter waiting times will improve the customer experience. So waiting times have great influence on customer satisfaction. So a shorter waiting time will be better for the consumers. So waiting time, a score of 9 was given for customer satisfaction. So why? Because customers generally prefer quick and convenient service in a short span of time, in a quick time. Similarly, service quality. If the waiting time is good, then obviously it reflects the service quality also. The waiting time is less, then it reflects the service quality also. That is why we have given a score of 9. Similarly, there was no connectivity between the waiting time and the transaction accuracy. That is why a weak relationship score of 1 is given. Okay, guys, do you got it?
Yes.
So this is how you have to calculate for the remaining things also. For online banking transactions, okay, for online banking system. See, what do you consider an online banking system? In online banking system, it includes phone banking, internet banking, and other digital ways of transaction. So actually, what is the customer satisfaction? When a customer is coming to the bank, then obviously it has very less relationship with the online banking transactions. Okay, because we have a separate team for handling the online banking transactions in the customer service. So a score of 3 for customer satisfaction suggests that the online banking transaction has a moderate impact. Okay, when a customer is preferring the branch, then obviously online banking doesn't have great influence. Okay, here we are handling only the customers. Here we are going to find out the causes and effects of customers who are coming to the branches. Okay, not about the digital transactions. So moderate score of 3 is given for the customer satisfaction when it comes to online banking system. Okay, but service quality, what does it mean by service quality? Quality score of 9 is given because if the digital platform is reliable, okay, it increases the service accessibility and convenience of the customers. Okay, if the digital platform, online banking or mobile banking which you are providing, if it is reliable, then obviously customers won't come to the bank, right? So that will, but in spite of that, senior citizens and some people who are not able to handle this digital transaction, they may be coming, but still that online banking system must be having good security and reliable. Then only the service quality will be higher. The service quality will be higher. So this online banking system has a strong relationship with the service quality. That is why we have given a score of 9. Okay, strong relationship, indicating the strong relationship, we are giving a score of 9. Similarly, when you are doing online transactions, digital transaction, you need higher level of accuracy. Otherwise, there will be a big problem. We will be losing money unnecessarily. So there was a strong connectivity between the online banking transaction and the transaction error or accuracy. Okay, transaction error or accuracy. So this is how you have to generate scores for the online banking system when comparing the customer satisfaction, service quality, and transaction accuracy. Okay, next we go for the staff availability or employees availability. See, when you go to the bank, you look for employee strength. If the employee strength is very low, then obviously it is going to take more time. Okay, so the number of employees available to serve the customers during the working hours is considered as a staff availability. See, if good number of staff is available, then that indicates the customer will get service immediately. So the customer will be getting the correct prompt service and the waiting time will be less. So obviously a score of 9. Okay, but that doesn't mean the service quality must be higher. There may be more number of staff, but there may be more number of helper staff only. That doesn't help you more, right? When it comes to certain services, you need more staff there. Suppose if you have more cash counters, it will be easy. But when the number of staff is more, and if they are not skilled enough, then obviously service quality will not be that much higher. So faculty numbers doesn't have any great connectivity with service quality. Okay, faculty members are more. If the staff is more, then obviously customer queries will be answered immediately. Okay, but it doesn't mean it has to be a quality one. So the connectivity between the number of staff available and the service quality is moderate only, and it has no connectivity. Okay, so transaction accuracy or this other things also, transaction accuracy and the staff availability also has a moderate or low connectivity only. So you can give either 3 or 1. Similarly, security. Okay, when it comes to transaction error or transaction accuracy, the customer satisfaction has a score of 9. Sorry, has a score of 3, right? Why? Because there is no connectivity between transaction accuracy and customer satisfaction. Okay, it is highly connected with the bank only. Similarly, service quality. What is a score that is connected with the service quality? It is 3. Why? Because service quality don't have any connectivity with the direct security measures. Okay, it is purely software related and bank management related. What about the transaction? Because if there is a problem in the security, the transaction may go for a great toss. So there is a high connectivity between the security measures and the transaction error. See, this helps you to find out the relationship between these inputs and the causes. Inputs and the causes. Okay, so the causes are the customer satisfaction, service quality, and transaction. You can add more. Okay, and these are the inputs which is provided from your side. Okay, these are the inputs which is provided from your side. So
customer satisfaction is a cause or effect, sir?
It is a cause.
Okay.
Okay, it is a cause. Okay, so now we are going to generate score for employee training. Okay, for employee training, what is the score? You multiply this 9 and 10, the important score and the score which was given by us, 9 and 10. And similarly for service quality also you multiply by 999, and for transaction error also 3 into 8. So here you at the bottom, are you able to see this, guys?
Yes, sir.
Bottom it is there. At the bottom you can see it.
Yeah, it's there.
So you can see it here. So yeah, like this you have to calculate for all the waiting time, online banking system, staff availability, and security measures, and you will get the total score for all the inputs. Okay, all the inputs which you are giving from the bank side. So which one is having topmost priorities? It's not this.
First two.
Take this. First two. So utmost importance must be given to these two things, employee training and waiting. Because this has greater influence in your process. So this has to be
employee training and online banking system, sir.
Oh, sorry. Yes. Sorry. Employee training and the online banking system. This is the topmost prioritized thing. So you have to give, yes, here it is. This is the most critical and important significant factor which you have to give immediate importance. Okay. So because it has a higher score as per our data which we have collected. See, the data has been collected, and with the help of expertise only, we have to provide this important score and the other scores. We cannot give it as per our wish. Everything should be done as per the protocols only, from the data and as from the team of experts only. Okay. From that, we are able to find out these three factors have, the last two factors have very least connectivity between the customer satisfaction and other two factors. But the first two factors have greater connectivity. First two factors have greater connectivity with the particular effect. So immediately you have to look into this. Okay. So altogether, we have to understand that the employee training, online banking system, and waiting. First three, the top three has greater influence on the banking key performance outcomes. Okay, that is how we have to use this cause and effect matrix to find out the important causes. Okay, and when it comes to limitations and benefits, this cause and effect matrix helps you to identify the most important causes, okay, potential causes, just like the impact control matrix. In the impact control matrix, we are finalizing the potential causes just based on the abstract data. There is no analytical or quantitative data in the impact control matrix, which we saw last week in the analyze phase. But here in the cause and effect matrix, we are using a simple quantitative data method procedure, mathematical procedure, to find out the scores of the potential causes, to find out the scores of the important factors which influences the problems or the outcomes, and we are able to prioritize based on the score also, first, second, third. Okay, so here our main focus is the alignment between the causes and the problems. That is the inputs and the causes. So it helps you to decide based on the data. So here we are not deciding based on some kind of knowledge or purely instincts or experience. Okay, so now apart from that, we can allot our resources like manpower or technology to the right problem based on the cause and effect matrix. So it is also a basic quality tool only. Okay, so since we are able to identify using the correct quantitative method, the risk of identifying the causes that influences the problem or that influences the key performance parameters, the failure is less. That is, the failure of choosing the wrong cause is very less. Okay, so when you are using a cause and effect matrix, the chances of choosing a wrong cause and investing in that wrong cause will be very less. Or the chances of choosing a wrong cause as a root cause also will be very less. That is what we consider as risk reduction. And apart from that, when it comes to the limitations, we can say, see, it is a team job. So the team members have to give the right scores based on the knowledge, experience, and the data. Then only your scores will be correct. Now, apart from that, since you have to collect the data from all process properly, it requires some amount of time. Okay. Then apart from that, data dependency is more. So you need to collect the data accurately. You need to have a data without error. Then only you will be able to play on this cause and effect matrix. Okay. That's all about cause and effect matrix. Any questions, guys?
बस बंद कर दो, दांत की दबा दो, जितनी नीचे है ना दांत की दबा दो.
Yes, then we are going for this hypothesis testing introduction. Hypothesis testing introduction. So where we are using this cause and effect matrix, the cause and effect matrix is used in the analyze phase. In the hypothesis testing also is used in the analyze phase to finalize the root cause. The cause and effect matrix is used in the analyze phase to identify the list of potential causes. Okay, but the analyze phase, in the analyze phase, if you want to pinpoint on the root cause, okay, if you want to pinpoint on the root cause, you have to go for the hypothesis testing. So just we are going to have a simple introduction about the hypothesis testing. Okay, so what is this hypothesis testing and why, when we have to use it and how we have to use it. So this is what we are doing in the analyze phase, right? First, we are listing the possible causes using brainstorming. Okay, then YY analysis. Then the cause and effect diagram is used to list out all possible causes in the image format. Then you are going to sort out the potential causes using impact control matrix. In order to find out whether the impact control matrix has given you the right potential causes, you are going to use a cause and effect matrix. The cause and effect matrix is far more enhanced and higher end tool when compared to impact control matrix for finalizing the potential causes. Why? Because impact control matrix we are just listing out based on the importance. Okay, I believe you remember the impact control matrix, right? The impact control matrix you are listing out. Okay, high impact, low impact. Okay, high control, low control causes. But in the cause and effect matrix, we are giving importance based on we are going to give scores based on the relationship, connectivity, importance. That is, if a cause is having high connectivity with the particular effect, then you give 9. So like that you are giving scores, and finally you are doing a simple mathematical calculations. You are arriving at the score for all the causes, and the causes which have higher influence will be considered for immediate recommended corrective action. Okay, so that is for potential causes. But when it comes to choosing the root cause, we are going for this hypothesis testing. So in the hypothesis testing, we are going to arrive at, using the hypothesis testing, we are going to arrive at a validated root cause. Guys, what we are going to arrive at? We are going to arrive at a validated root cause. Okay. So what is this hypothesis testing? See, it is a very important tool in Six Sigma methodology. Okay. So we are going to use this hypothesis testing for making a data-driven decision. What we are going to use? We are using data, okay, in the hypothesis testing to make decisions. What decisions we are making to decide whether this is a root cause or not? Okay, as I said already, it is used in the analyze phase in the DMAC methodology or in the zigzag methodology to test the assumptions. What do you mean by assumptions? We are assuming that these potential causes may be the root cause. We doesn't know, right? There may be 5 or 6 potential causes. So we are assuming these potential causes may be root cause. So we want to test that, and we want to validate whether these potential causes are the real root causes. So it is a wonderful procedure to validate our claim. Okay, we are making a claim. What claim we are making? We are saying, sir, because of this particular tool only, the productivity is less. Because of poor employee training only, the customer satisfaction is less. We are making a claim. So the claim has to be validated. How? Through data only. Claim has to be validated through data only. Then only we can either accept or reject the claim. Then only we can either accept or reject the claim. So remember, hypothesis testing is used to validate your claim of root cause. You may be claiming this is a root cause, this is a potential cause. In order to validate that, they are making. So the hypothesis testing is what our team, our Six Sigma methodology team, project team, is using to identify the root cause of the problem. Because we have a problem which we have identified in the define phase, and we have confirmed the problem in the measure phase by collecting the data. Then in the analyze phase, we are going to confirm the root cause for the problem. For that, you are using hypothesis testing. So what are the main tasks which our team has to do, and how it helps our team? See, here it helps to make decisions based on data, not on assumptions. See, our team is going to make or decide the decision based on data, not on experience or assumptions. And apart from that, it helps our project to verify whether the factor, that is, whether the cause is really creating the problem, whether the cause is really affecting the problem. Okay, that is what we are going to verify. Guys, do you get it? There is a cause. For example, let us say, let us go to a bank. Employee training. Whether the employee training is affecting the service quality, we need to verify through data. We can say, yes, sir, it is affecting the data. We can say it orally. That is a claim. but we have to verify through data that factor, employee training, whether it affects the customer satisfaction, whether it creates a customer satisfaction, or whether it creates poor customer satisfaction, has to be verified by data. That verification is done in the hypothesis test by our team. Apart from that, it helps you to separate the real causes which has influence with the problem from the random variation. See, what is random variation? Because of some natural causes also variations may happen, problems may happen. Because of some real, because of some random variation, because of some random problems. Okay, because of some random problem, because of some random causes. What is mean by random causes? During the control charts, one of you asked, sir, in the first 5 days, there was a problem. So there was a fluctuation. After the next 25 days, there was no such fluctuation. What I have to do? You asked a question like this, right? That is because of random variation. Sometimes random variations may happen. So we need to separate those random variations which occurs very rarely and which has very least influence in the problem. So this hypothesis testing helps you to separate, segregate, individualize, and remove the random variation from the real causes, which may be the root cause. Okay, so this is why hypothesis testing plays a major role and in helping our team. Okay, so it helps you to make the decisions correctly without any actions, verify whether our claim is true or not, and unknown random variations are eliminated from the race, from the list of the real causes. Okay, then apart from this, the hypothesis testing will statistically checks what is statistically using statistical features like mean, that is average, range, mode, standard deviation, skewness, kurtosis. Using this, it will help you to find out whether a suspected cause, you have a doubt in a particular cause, whether it might be the root cause. So the hypothesis testing statistically will help you to prove whether this cause is important or not. Okay, whether the process changes created, okay, whether the process changes created measurable differences. That is, see, whether the cause which you are choosing is creating measurable differences. What does it mean? See, for example, is the let us go to the cause and effect diagram. See, we have a cause called staff availability. Whether the staff availability has a influence on the customer satisfaction. Okay, yes. How? Because if more staffs are available, the customer scores are high. Similarly, let me give you another simple way. Whether the staff availability, okay, it is, let's go for the online banking system. Whether the online banking system has influence on the transaction error. Yes, the online banking system will have an influence on the transaction error. How? If the transaction accuracy or transaction error. See, if there was a problem in the online transaction, then there will be more transaction errors. So we are able to measure, we are able to find out this online transaction system can have a impact on the transaction error or accuracy. Okay, so we are able to collect the data and prove it. Okay, so hypothesis testing also helps you to find out the measurable differences between the causes and the effects, causes and the effects. Okay, and also it helps you to check whether the variation is due to random or actual cause. See, sometimes we may get a higher temperature, but it may not be due to fever. Because of some continuous work and tiredness, we may have high temperature, but it may not be due to fever. So if you take rest, and actually it will get cleared within a day or within a night. So that is a random cause. Okay, it is not a, and there is no illness or sickness behind that. So we need to segregate. Okay, find out difference between those. Okay, so hypothesis testing helps you to find out whether the cause is due to random or due to a particular reason. That means whether the particular variation occurred because of a background reason or there is no reason at all. We have to confirm that. Hypothesis testing helps you to check that also. Guys, this hypothesis testing will be a bit vague topic. Okay, so after using the tool only, you'll be getting more knowledge on this. So don't worry. So why hypothesis testing is most important in the analysis phase? Because it helps you to validate the root cause. That means it confirms whether the particular cause is real or not, whether it is having a high connectivity with the problem or not. Then it eliminates assumptions. All decisions are based on data which was collected without error, with minimum error. Then it helps you to find out the real potential causes which is affecting the performance. Okay. Then it helps you to identify the reason for the variations. See, in the control charts, you are finding the variations, right? So it helps you to, the hypothesis testing helps you to find out the source for the variations. On control charts, we are just finding the variations. We doesn't find what is the real source for the variation. But hypothesis testing will help you to finalize the source for the variation. Since you are deciding based on data, statistical evidence, the decision making will be done in a more confident manner when you choose a hypothesis testing. Okay, guys. So this is all about this. Okay, hypothesis testing. Okay. So how to do this hypothesis testing? Just now we saw what is hypothesis testing and how to, what is the importance of hypothesis testing and what is the purpose of hypothesis testing. Okay, how to do this hypothesis testing? What is the meaning of hypothesis? Hypothesis means an assumption. Hypothesis means an assumptions are a claim. That is what do you mean by hypothesis. Okay, so we have a manufacturing or a service sector. Okay, like a bank or a hospital or a manufacturing unit or a food processing unit or a hotel. Okay, so every day we are serving customers, we are making the products and we are serving the customers. So we have a population. Okay, we have a population. So we have some problem in the population and we claim this may be the reason, cause for the population. That is an assumption. That is an assumption. So in order to ensure whether the assumption is real or not, we are going to use this hypothesis testing. Okay, and this hypothesis testing is using statistical techniques. What is statistical techniques? Mean, median, that is average, mode, median, and all these statistical features and statistical tools are going to be used. Okay, so remember, hypothesis means assumptions. Okay, hypothesis means assumptions. We are going to assume this is a root cause. That should be proved by the hypothesis testing. So that hypothesis which we are, that is our assumption is going to be tested and proved whether it is true or not. That is called hypothesis testing. Are we clear, guys? There is no sound from anybody. Our assumption is going to be tested and proved whether it is real or not. That is called hypothesis testing. So it is purely a statistical method only. Okay, data is to be collected and based on data, either we infer or we don't infer. Okay, so we used to make decisions and interpretations purely based on population sample data. We have to collect samples and we have to ensure that the samples which we collect have minimum error or no error. Based on that only, we are going to make the decisions. Okay, so this is how hypothesis testing starts. Okay, in hypothesis testing, you have two types of statements. In hypothesis testing, we have two types of statement. One is alternate hypothesis. Guys, listen, one is alternate hypothesis, which is represented as H1 or HA. Another one is null hypothesis, which is represented as H0. You have to keep this in mind. One is alternate hypothesis, null hypothesis. Okay, so first, what is a hypothesis? Hypothesis is a claim which we are going to make. Hypothesis is a claim which we are going to make. See, there was an example. company claims that the bulb which they are manufacturing is having an average life of 1,000 hours. What is the hours of life it's having? They are claiming, guys. They are claiming it is having 1,000 hours. Okay, so we are going to write a hypothesis statement. Okay, first, the hypothesis statement is the statement or the claim which is given by your team or which is given by your Six Sigma methodology process that this may be the root cause. Then you have to write two hypothesis statements. One is null hypothesis and another one is alternate hypothesis. The null hypothesis and alternate hypothesis are entirely opposite to each other because the null hypothesis states the claim which was made by the company, okay, has no effect or no difference. Has no effects or no difference. That is, the claim is same as done by the company. The claim is same as done by the company. That is, this is the nature of the null hypothesis. That is, the null hypothesis states there is no change, no improvement, no difference. Guys, you need to understand this null hypothesis. You need to understand this hypothesis statement, null hypothesis and alternate hypothesis very clearly. Then only you'll be able to understand the hypothesis testing. Are you understanding, guys? For example, I am making a claim. The weather is because of poor high pollution. This is my claim. What is null hypothesis states? Null hypothesis states, yes, no change, no improvement, no difference. As it is. Null hypothesis says as it is.
As it is means your claim is true.
Null hypothesis says yes, as it is. No change in my statement. No change in my statement. Okay. What does alternate hypothesis says? It differs from the null hypothesis. See, here you have to be very carefully approach it. The alternate hypothesis says it differs from null hypothesis. It doesn't differ from my claim. It differs from the alternate null hypothesis. Or you can say it the other way. The alternate hypothesis, okay. As here there is a manufacturing company wants to know whether the new machine reduces defects. Okay. And the null hypothesis says no defects. The machine does not reduce defects. Alternate hypothesis says otherwise. Yes, it reduces defects. Okay. Here the claim is, does the machine improve quality? Okay. Alternate hypothesis says, yes, it reduces quality. It differs. Null hypothesis says it does not. Null hypothesis says it does not. So let us first start with alternate hypothesis. Alternate hypothesis always goes for the change, goes for the difference, accepts the difference, accepts the improvement, accepts the change. But null hypothesis says as it is, no change, no improvement, no difference. Got it, guys? So first you have to make a hypothesis statement. The hypothesis statement is a claim which you make. It may be the cause or it may be a performance statement. The alternate hypothesis approves that the change has happened, a difference has occurred. Okay, improvement has really happened there. Okay, but null hypothesis says yes, no change, no improvement, no difference has happened. Okay, this is not the cause. This is the if you say this is the root cause, null hypothesis says yes, this is the root cause. Alternate hypothesis will say this is not the root cause. Okay, so let me give you some more examples so that you'll be able to understand more. Give you more examples. So in the hypothesis testing, you have to be very clear. Remember these things. Hypothesis statement. Hypothesis statement is a claim. Hypothesis means assumptions. So you are assuming this is the cause for the problem. Okay, so that is what we say it as assumption. So once you assume, then you make two other statements, that is null hypothesis and alternate hypothesis. The null hypothesis claims there is no difference, there is no change, there is no variation. there is no impact. Alternate hypothesis says, yes, there is a change, there is an impact, there is a variation. Okay. For example, here a manufacturer claims that the diameter of the shaft is 20 mm. Okay. It claims the manufacturer is supplying a lot of shaft to a company. Okay, another company. So he is claiming that the diameter of the shaft is 20 mm. So a random sample of shaft is taken from the production line to verify this claim. So in this case, the null hypothesis says yes, 20 mm. But the alternate hypothesis says it may not be 20 mm. It differs, it varies. Null hypothesis accepts what it is. Okay, null hypothesis accepts what it is. Okay. Let us take another company. A company, they are changing a new machinery. Whether the new machinery has reduced the production cycle time, whether it has decreases the production cycle time or not. Null hypothesis says no reduction in time. Alternate hypothesis says reduction in time. See, H-O means null. 1 or A means alternate. Got it, guys? So the company says the new machine, because of the new machine, okay, the cycle time has reduced. Null hypothesis says no change, no reduction. Alternate hypothesis says reduction. So we are going to, what we are trying is we are going to prove the null hypothesis is wrong. If the null hypothesis is proved wrong, then obviously alternate hypothesis is correct. Guys, you have to listen carefully, because this hypothesis testing is a different kind of topic in the entire Six Sigma tools, because it is quite bit naive. If you listen carefully, then only you'll be able to grasp it. That is why I'm taking it so much time. See, here the claim is the new machinery reduces the cycle time. So as per null hypothesis, no change. Yes, no reduction in cycle time. Alternate hypothesis says yes, it reduces the cycle time. Okay, now your job is to prove, okay, the null hypothesis wrong. If the null hypothesis is wrong, then what is actually correct?
Null hypothesis wrong. There's a reduction.
Then obviously alternate hypothesis will be automatically
Valid.
correct. Okay, suppose if null hypothesis is proved correct, then obviously there is no reduction in the cycle time. So you are not going to touch the alternate hypothesis. Okay, so you are going to check whether the null hypothesis is wrong or incorrect. If the null hypothesis is proved correct, then there is no reduction in time. The null hypothesis is proved wrong, then obviously alternate hypothesis will be defaultly correct. Have you got it, guys? Yes, no?
Yes.
Okay, so this is how you have to frame the null hypothesis and alternate hypothesis. Okay. See, here there is another scenario. A factory tests whether the batch of products meet quality standards. Null hypothesis does not differ. It says, yes, it meets the quality standards. Alternate hypothesis says, no, it does. It differs. It does not meet the quality standards. Okay. So I can give a lot of examples like this. Okay, here there is another example. Most of us are from manufacturing. Okay, I have taken a lot from manufacturing. A factory introduces a new quality control method, and it wants to test whether it reduces the defect rates. So what will be the null hypothesis? Yes, no change in defects, no improvement in defects. That is a null hypothesis. That means null hypothesis will always agree with the claim. It will not make any difference to the claim. So no improvement, no change, no difference. That is the stand of null hypothesis. Alternate hypothesis always differs, varies, changes. Alternate hypothesis says the defect rate after implementing the new method is lower. So improvement, changes. Got it, guys? Okay, this is how you frame null hypothesis and alternate hypothesis. Okay, for example, let me make a statement. Whether the digital transactions has reduced the load of banking. You guys have to give me the null hypothesis and alternate hypothesis. Is the digital transaction, is the implementation of digital transactions in India has reduced the load of banking
Null
transactions.
hypothesis is digital transaction have not reduced the load of banking, and the alternate hypothesis has the digital transaction have significantly reduced the load of banking.
Yes, that's it. Good, excellent. That's it. That's all. So if you have understood this, then obviously it is done. Okay. So now we go to the methodology of how to do this null hypothesis and how to do this hypothesis testing. Okay. Before going to this hypothesis testing, you must know about this type 1 error and type 2 error. Okay, what is type 1 error? See, rejecting a true null hypothesis is type 1 error. What is true null hypothesis? What is null hypothesis? Null hypothesis is claiming there is no change. Okay. When you reject that null hypothesis, when it is true, that is type 1 error. Okay, now let us take the same example which Pranit said. I said the digital transaction has reduced the banking load on the banking system. What is the null hypothesis? He said, yes, it has reduced. Okay, it has reduced. That is a null hypothesis. Guys, do you agree with me? Yes, no? Guys, are you there?
So it was the opposite.
Null hypothesis is there is no change, right?
Yeah, no change.
Yes.
No
Yeah,
change. That
initially you
is,
told there's change.
yes, null hypothesis, as I said, digital transactions has reduced the load on the banking. Okay. Now, what is a null hypothesis? You have to say. Guys, you have to say. Just repeat what you said.
Not reduced the
Null is not
banking
reduced. Alternate is reduced.
See, what is the null H naught? What is the null hypothesis here? Whether the whether the digital transactions has reduced the load on banking people.
digital transaction not reduce the
Do not reduce.
not reduce
Not reduced.
the
Okay.
that is
Not
size
reduced.
0.
Okay. The not reduced. Suppose if that is true. Okay. If that is true, and if you reject that, then it is type 1 error. If that is true, guys, let me repeat it. If that is true, or let me take another example. Diesel vehicles are responsible for air pollution. I am making a claim. Diesel vehicles are responsible for air pollution. What is the null hypothesis here?
They are not responsible.
They are not responsible.
See, what is null hypothesis here? Null hypothesis means, see, what is null hypothesis here?
No change. Yeah, matlab it is responsible.
It is
Yes.
responsible.
Yes, it is responsible. See, always remember this. Null hypothesis means no change, no difference, no improvement. Okay. So my claim is diesel vehicles are responsible for pollution. So here the null hypothesis statement is yes, as it is. What about alternate hypothesis?
The opposite.
Not responsible.
Yes, not responsible. No, it's different. Now, If null hypothesis is true, okay, I am making the claim, you are making the null hypothesis statement. Okay, no problem. Let me type it so that you people will understand it more. Diesel vehicles responsible. Okay, this is the null hypothesis. Okay, then what is the opposite?
Not
When it
responsible.
comes, not responsible.
Yes.
Not differs. Okay, now see this is based on the statement I make. This is based on the statement I make. So I have to make the hypothesis statement clearly. Okay, what is my claim? My claim is diesel vehicles responsible? Is diesel vehicles responsible? This is my hypothesis statement. Hypothesis statement. Okay, so you have to be very clear with making the hypothesis statement. That is important. Based on that only we are making this null hypothesis and alternate hypothesis. Okay, now diesel vehicles responsible. That is null hypothesis. Not responsible is alternate hypothesis. If this is, I collect the data. I collect the data and I found this is true, but I have rejected it. That means I have disagreed. I have denied it. Then it is type 1 error. Got it, guys? If I rejected a null hypothesis when it is true, that is called type 1 error. If I fail to reject a null hypothesis when it is false, suppose I collect the data and I found that diesel vehicles are not responsible. Just for an assumption I am saying. Okay, I collect the data and I found that diesel vehicles are not responsible. But I am accepting null hypothesis. What is null hypothesis? Null hypothesis, diesel vehicle responsible. But the actual data shows diesel vehicles not responsible. So I have accepted a null hypothesis when it is false. That is said in an indirect manner. That is, I am failing to reject the null hypothesis when it is false. Is called type 2 error. Guys, do you understand this or not? This is a bit chaotic. That is why you have to take time to understand. See, type 1 error is, I am making a claim. This is a claim. Is diesel vehicle responsible? Null hypothesis is diesel vehicle responsible. Alternate hypothesis not responsible. So if this is true as per the data, and if I accidentally rejected it, if it was true, then it is type 1 error. If I accepted it, if it was false, then that is type 2 error. To be very simple. If I accepted it, if it was false, that is type 2 error. Now, do you got it? Give me yes or no. If you said no, I will explain it in other ways. Guys, what's happening? Whether you are getting anywhere?
Yes, sir.
The type 2 error needs to be explained again.
One more example.
Type 2 example is the opposite of type 1. See, instead of rejecting, if I put accepting, ACCEPTING, accepting. Okay, accepting when H0 is false is type 2 error. Accepting when H0 is false. Okay, let us take another example. Okay, obesity is responsible for diabetes. Is obesity responsible for diabetes? Let me type it so that then only you'll be able to grasp it. Is obesity responsible for diabetes? Okay, what is a null hypothesis here, guys? It's a null hypothesis.
Yes, it is responsible.
Yes,
Rejecting obesity.
Okay, alternate hypothesis? No.
No, it is not
Different.
responsible for that.
Okay. Now, what is type 1 error? What is type 1 error here?
Rejecting.
You reject when this statement is true. You reject when this statement is true. See, suppose you collect the data, okay, and for some unknown reasons, the data is maybe having an error, or you have some kind of issue, and you kind of some kind of historical data. Based on that, you are making a decision. That decision is you reject that particular claim. You reject that particular null hypothesis. What is a null hypothesis? Yes, obesity is responsible for diabetes. You reject it. But actually, obesity is responsible for diabetic. That is true. And your null hypothesis is also states that only. What is a null hypothesis? Yes, obesity is responsible. Null hypothesis is, yes, obesity is responsible. But you reject it. You reject it.
So reject it means instead of yes, if you put no, if in H0, that you mean by rejecting it, or?
That is, you are not accepting it. You are saying, no. As per my data, it is not. You are saying, as per my data, your claim is incorrect and you are rejecting it. You are not accepting it. That is the answer. So that is type 1 error. I am saying, sir, obesity is responsible for diabetes. Okay. That is it's not. That is a null hypothesis. But you fail to accept it, even though it is a true, even though that statement is correct. That is type 1 error. See, this is a error. Why? Because you are not accepting a correct statement. You are not accepting a correct statement. That is type 1 error. Got it now?
Sure.
Still you are having some confusion, huh? See, this
basically,
topic,
this is
This
a kind
type
of
1 and type 2 error.
conversation between two people, right, sir? So if
Yes.
I'm claiming that H0 is yes, then another person who is having some other data is rejecting my statement. So basically, this is a conversation between two-person kind of thing.
Yes, actually, there is a common claim, and two people are having different approach towards a claim. One is yes, no change. Another one is no, we don't agree. That is difference. Okay, so our job is to take the first one, the person who agrees, and try to prove him either wrong or right. It doesn't bother about the H1. Okay, so for example, let us take Muralidharan and myself. The common statement is, doctor is saying obesity is responsible for diabetes. So Muralidharan is saying, Muralidharan is H0. He is saying, yes, it is responsible for diabetes. But later onwards, it was proved, it was proved correct. But our company rejected the claim. The reason for diabetics was obesity. That was correct. Muralidharan also said, yes, it is responsible for diabetes, but the hospital rejected that. So the hospital has made a error. That error is called type 1 error. Got it, guys?
Yes, sir. Clear
Yes,
for me.
sir.
Okay, now let us go to type 2 error. See,
It is more confusing now, sir.
see, let us keep it very simple, guys. Let us give me a very simple example. Okay. See, the company says the bulb will glow for 1,000 hours. Okay. Null hypothesis, yes, 1,000 hours. Alternate hypothesis says, no, not 1,000 hours. Now, if the bulb glows for 1,000 hours, but I failed to accept it and I didn't purchase it, that is type 1 error. Got it, guys? Guys, do you got it? Still no answer. Come on, guys, see.
Yes, sir.
No, sir. The 1,000 hours they're claiming, but you are not buying, thinking that it will not.
Yes, I failed. I rejected it. I thought that it will not glow for 1,000 hours. So I rejected the purchase. But actually it was true. It was glowing for 1000 hours. So the error which I made was called type 1 error.
How do you know? So I have rejected, but how do you know it withstands 1000 hours? I may
Based
not know.
on
No?
the
Once a rejected person doesn't know,
yes,
it is
based on
withstood.
that. Yeah, but actually this is a practical scenario. So you are asking question. But based on the data which we collect, we are proving it.
So,
Okay, sir, you can continue.
just
Maybe
for,
the
just
further
to
course.
See, actually, after doing the test only, you will understand these things. But
Yeah.
actually, this was the introduction. So I am trying to prove the terminology only. But
Okay,
actually,
understood.
I am also trying to prove it practically. You are also trying to understand it practically. That is the
Okay, sir.
difference.
That like that
Yeah.
mini tab,
So,
the p value less than that 0.05, so that will give the result whatever we are taking.
yes. Yeah. Of course.
We can
Of course.
continue, sir.
Yes, actually. So when I reject the data, when I reject the claim, okay, when it was true, that is called type 1 error. Suppose if I accepted that and actually it was not true. See, the bulb actually cannot glow for 1000 hours, but I accepted it and purchased it. That is type 2 error. Got it, guys? If it is otherwise, other way around, that is type 2 error. See, you will understand it only after doing the test only. There are so
Okay,
many
sir.
tests.
Yeah.
Okay.
We
So
will
the
do the test.
important thing, the important thing which you must remember is, right, what is the purpose of hypothesis testing? To prove whether the assumption is correct or not. So in hypothesis testing, you have to make three statements. One is the hypothesis statement, then null hypothesis and alternate hypothesis. Always remember, you have to make the correct hypothesis statement. Okay. Then based on that, you have to make the null hypothesis. Null hypothesis says, yes, whatever you say is same. Alternate hypothesis differs from whatever you say. So, yes, because what is your question?
Yes, sir. From where do we derive this hypothesis statement, sir? From once we narrow down this potential root causes, from there for each root causes we need to derive hypothesis statement. Like
yes, absolutely, you are correct. From potential, for example, if you are having 5 or 6 potential causes, what is the actual root cause for our problem? We have to derive that. We have to finalize that. For that, we are going to use this hypothesis test. So hypothesis testing, first we make a statement. Then you collect data regarding that statement. Then you make the hypothesis testing. Hypothesis statements. Say first you make the hypothesis statement, null hypothesis, alternate hypothesis, then go for collecting the data. Then based on the statistical calculations, you decide in that decision, if you there is a possibility you can do this two type of errors. Okay, guys. So in the final, there is a possibility you can do these two kinds of errors. Either you can reject a null hypothesis when it is true, or you can accept a null hypothesis when it is false. Okay.
So once we identify the potential root cause, if, for example, if I'm having the 5 potential root cause, so for each 5 items, we need to derive this null H0 and H1.
Yes, you have to go for the statements one by one. You'll be able to find out the p-value, and based on that, you can decide.
Okay.
See, actually, this is a procedure for this hypothesis testing, guys. First, you have to frame the hypothesis statement. First, you have to frame this hypothesis statement. That is an assumption statement. This obesity is responsible for diabetic. Or you can say, there may be another claim. Yes, genetics is responsible for the diabetic. Or poor lifestyle is responsible for diabetic. So you may have three statements. So first frame the hypothesis, null hypothesis statement, alternate hypothesis statement. See, the important thing is you have to frame the hypothesis statement very carefully. If you frame the hypothesis statement in the other way around, the null hypothesis and alternate hypothesis will go inverse. So you have to be very careful. Then you have to fix the level of significance. What is this level of significance? The level of significance is the error which we agree to accept. See, all the data which we collect from a process, there is a possibility of some percentage of error, right? because of natural error or random error. So we agree for a error percentage. That error percentage must be always in between 1 to 5. That is what we call as alpha risk and what we say it as level of significance. Got it, guys? First, you frame the hypothesis statement, then H0 null hypothesis, H1 alternate hypothesis. Then you fix the level of significance. That means the error which you agree to accept. Okay, the error which you agree to accept must be in between 1 to 5%. You have to fix it. Don't go for more than 5%, which is not recommended. Okay, so third step is you have to refer and analyze the data which is available regarding that particular potential cause or assumption. If there is no data available, then conduct a real-time experiment and generate a similar data. So for example, you could have seen in the police criminal cases, if a crime has happened in a particular area, the police will make that particular thief or the murderer do the same activity again and they will capture it in the video. Have you seen that? Have you seen that?
Yes, sir.
Yes, sir.
So that is generating the data by conducting the experiment in similar conditions. So here also, suppose if you have the data to prove that hypothesis statement null or alternate, you go and fix the level of significance and calculate the statistics. If you don't have the data, you have to conduct the experiment and generate a similar data. That is, you have to go for a prototype or you have to go for a pilot experimenting and you have to collect the data. Then you have to calculate the required statistics in the data. Okay, and in the same time, you have to estimate the error in the data. That is the one which we spoke about earlier. That is alpha risk. So here we are fixing the level of risk, level of error. Okay, it must be in between 1 to 5%. Now, after collecting the data, you are calculating the statistics, and there also you are calculating the real error in the data. If the real error is more than the one which is fixed by you here, the second step you are fixing the error, right? The second step you are fixing the error. The error, for example, you are fixing at 5%. Again, in the fourth step, you are collecting the data and using the statistics. There also you are estimating the error. There is a method for that, don't worry. If the error is more than 5%, you reject the data for making decisions. You don't accept the data for making decisions. If that error is less than 5%, then use the data and make the decisions. Guys, do you got it? So in hypothesis testing, first you frame the hypothesis statement. Yes, obesity is responsible for diabetic. Then null hypothesis, the same as it is. Alternate hypothesis, no, obesity is not responsible for diabetes. Then you are going to fix the error level or risk level. You have to decide it as per your process. You have to decide in between 1 to 5%. Okay, you have to decide how much risk you are ready to take is what you have to fix. Yes, what is the question, please? Yes, Nirmal, we didn't get you. I'm not able to hear your voice. Nirmal, could you please type the question because your voice is not audible. Anybody able to hear what Nirmal says?
No.
Okay, so always remember this is the procedure for hypothesis testing. So don't worry about, guys. Very simple. First, make your claim. Nirmal, you type the question in the chat. That is the best thing which you can do. Because your voice is not audible. Nirmal, you please type the question in the chat. It is not, your voice is not audible. So, see, the second level, the second stage, the second step itself, you have to fix the risk which you are ready to take. Whether you are ready to accept a error of 1%, 2%, or 3%, or 4 or 5. You have to fix that. Then you have to collect the data or refer the data and conduct the statistical test. In the statistical test, if you found that the error is more than the percentage which you fixed in level 2, in step 2, reject that data. If it is less than the percentage which you fixed, if it is less than the percentage you fixed, there you got it, right? If it is less than the percentage, that is what we mean by less than alpha. If it is less than the percentage, what is it is fixed, then use the data. If it is more, if the error in the data, if it is more than 5%, don't use that data. Use your expertise and team knowledge alone to decide the root cause. Guys, do you get it or not? At least the steps.
The statement is little confusing, sir. If the uncertainty is more than alpha, you told something that don't use the data, something like that. If you can put it will be.
Yes, actually,
the
here you are collecting data. Here you are collecting data.
Yes, sir.
Okay. If the data contains error, then whether the decision which you make will be correct or not, it will influence the decision which you make. Right? So we are fixing the percentage of error to be accepted here. The error percentage which you are ready to accept must be in between 1 to 5%. It's
clear.
So if the error percentage is less than 5%, use the data and decide the root cause. If the error percentage is more than 5, that is the symbol means.
Yeah, don't use the experimental data. You can add here, don't use the experimental data. And use only knowledge alone. You can add that, don't use the experimental data. It will be like a spoon feeding.
Yes, don't use the experimental data. Okay, then you have to use your team experience, knowledge, and previous informations. That's it. Okay, because the data which you have seems to have certain percentage of error, which is beyond the acceptance. Okay. So here only we are considering the type 1 and type 2 error. See, in the step 5, we are deciding whether this is a root cause or not. But in step 5, if you have accepted a null hypothesis, okay, when you have rejected a null hypothesis, when it is true, then that is type 1 error. You have made a type 1 error. Okay. Again, I am putting it in this way. If you have rejected a null hypothesis, okay, when it is true, that is type 1 error. If you have accepted a null hypothesis, when it is true, okay, when you have accepted, okay, let us not bring it once again. That is, when you accept a null hypothesis, when it is false, that is type 2 error. Okay, we are making a decision here. After step 5, we are making a decision. Whether the decision, if it is correct, there is no question. If the decision is wrong, it will be either of type 1 error or type 2 error. Type 1 error is you accept it when null hypothesis is type 1 error is you reject when null hypothesis is true. You accept it when null hypothesis is false. That is type 2 error. So after step 5, there is a possibility for you to assess whether this decision is correct or it falls under type 1 or type 2 error. Okay, for your information, you have so many types of tests. Okay, hypothesis Z test. When you want to compare 2% of samples, average of samples, and the data is continuous. When you have more than 1 or 2 samples, okay, when the population is large, then you have to use a Z test. Then chi-square test is there. When you are doing this test, all your doubts will be cleared. Next week, you are going to do this test. Got it, guys? Okay. Next week, you are going to do all this test. Set test, T-square test, F test. Then you have this regression analysis, which is already correlation, proportion test. Proportion test. Okay. Then you have this one sample t-test, independent t-test, paired t-test. So depending upon the type of samples and groups, you will be designing the test. Then you have one-way ANOVA, two-way ANOVA. All these are hypothesis test only. Depending upon the type of data you have, you will use this test. These tests will decide whether the error is alpha is less than 5% or more than 5%, or P. Sometimes they used to call this as P. Okay, P is, so if alpha is more than 5%, then reject that data and decide based on your knowledge. If alpha is less than 5%, use that data and you decide. That is what this test will help you to do it. Okay, so many tests, see, so many tests are there. So you'll be doing most of this test. After doing this test, the hypothesis testing will be clear to you. But before that, you must remember this basics. Hypothesis statement, null hypothesis, alternate hypothesis. Okay, level of error or significance. We used to call it as significance. Then collect the data, do the statistical tests. If the data error in the data, if it is more than the 5% or alpha which you fix, reject it. Less, accept it. Got it, guys?
Yes, sir.
Yes, sir. I think definitely there will be a bit of doubt in your mind, but everything will be clear once you do the test. Okay, because this hypothesis testing is quite a sensitive topic in the entire methodology. It is a different tool because we are going to prove the assumption is either false or not false. Okay, we are proving it other way around. That is the difference. We are proving the assumption is false or not false. Okay, so that is why the confusion prevails. So remember this null hypothesis and alternate hypothesis. Okay, so now you know what is null hypothesis and alternate hypothesis, right? Guys? Yes, give me yes or no.
Yes.
Okay.
Yes.
Do you understand what is type 1 error and type 2 error?
Yes, sir.
Please remember this steps. Okay. So, and apart from that, no need to worry about this test. You have so many types of tests. For different types of data available, you will be choosing different tests and you will be working on this in the next week. Okay. So you'll be given an Excel sheet and the Excel sheet will be also shared with you. And in that, there is a formula for all these things. So no need to worry. Okay, guys?
Okay, sir.
Yes, sir.
So actually today we have seen 3 tools. Control charts, quite a visible, practical, transparent tool. Then cause and effect matrix. This hypothesis testing, I have not run the hypothesis testing. I have given only introduction. So don't worry about the bit of doubt you have in the introduction. Once you execute it, you will be clear. Got it, guys?
Yes.
Yes, sir.
Yes, sir. Yes.
So in cause and effect, we are looking for that fishbone or Ishikawa, that type of charts. So
See,
will
the
it follow
cause
in the
and
next
effect,
class or?
we have already seen that cause and effect diagram, right?
Correct. So that is different than this cause and effect.
See, actually, I will share this one. See, the first step is listing the possible causes. The possible causes are listed using brainstorming, Y-way analysis, and Ishikawa.
Okay.
The potential causes are listed using impact control matrix and cause and effect matrix.
Yeah.
Okay. See, for the cause and effect diagram, fishbone diagram, and Y-way analysis, brainstorming. These are all used for listing all the possible causes. But for next stage, for potential causes, you can use the impact control matrix. But impact control matrix doesn't have any quantitative method, any quantitative analysis. Okay, it simply says low impact, high impact, low control, high control. But we come to cause and effect matrix. It has some quantitative analytics. That is, it uses 1, 3, 9 for as a scoring method. So you are getting some scores which gives you more idea about which cause is having more influence on the problem. Okay.
Okay. In some industries, what they do, the first level cause and effect, that is probable causes. So that they will have some, for example, some 20, 25 causes.
Causes, yes.
And next possible cause, the same thing they will reduce to some 10 or 5. After that, that relation diagram they will put, and finally it also will be in the Ishikawa. Only some 3, 4 the root cause will come after that relation matrix.
Yes.
So
Yes,
there is a different practice.
Yeah, yes, companies, they will follow their own methodology.
Correct.
Okay, but if it is successful, then that is good. But in Six Sigma methodology, we follow this protocol only.
Okay.
Okay, because any tool can be used in any place depending upon its impact on the decision making. Okay, suppose if you can use a Pareto chart also here, there is no wrong in that. But if it is satisfying your purpose, that is the thing which we have to see. But here we are very specific. Yes, guys, you can use the possible causes generation by brainstorming. First, a simple tool, then YV analysis, then put everything in the diagram using a cause and effect Ishikawa diagram. Okay, if I say you are going to use the same tool again, there is no strength in it. So we go for a much better tool than that. That is impact control matrix. Then cause and effect matrix is even better than that. Okay. Because here everything is decided based on data and data. So wherever our final decision is going to be made, we try to bring some quantitative data. That is what cause and effect matrix does.
Clear, sir. Okay, sir.
Okay, guys.
Good night, sir.
Okay, guys. Thank you. Good night. I believe. Yes, it's just like sitting back in the colleges after 20 years, fully confused, still sailing. Who is that?
Right. Yeah. Thank you, sir.
Robert
Right.
Williams. It's just like sitting back in the college 20 days after 20 years, fully sailing to find the lighthouse. Robert Williams, hypothesis testing is giving you some highlight. See, you could have asked more questions, nah?
Next class, sir, during practical session.
Yes, practical session. So if you still want to stay back and ask any questions regarding hypothesis testing, I am ready to answer you. For people like Robert who are trying to find the lighthouse.
So this recorded
okay, sir. Thank you, sir.
Recorded video is shared.
Yes, it will be recorded and shared in the next week.
So normally we got that PDF file only, 1 or 2 PDF file, and
actually, please keep in touch
recorded
with
file is so
Prabhakaran.
far not shared. I think I don't know about other participants.
It is uploaded on the Tuesday. Last time it was uploaded on Tuesday.
So actually, it will be uploaded in the app. You have
school, Gmeet.
Classroom.
Classroom.
Okay. It's not in the WhatsApp sharing. Okay, I will go to the classroom. Thank you.
You can check on Tuesday.
Yeah. Thank you.
If you have any difficulty, guys, please contact Prabhakaran immediately. He will give you a valid answer and correct date when it will be getting uploaded, when you will get it. All these details can be obtained from Prabhakaran.
Prabhakaran contact number, can you put in the chat, sir? If you don't.
If you don't have, I will just put.
Yeah, his number I don't have because only Rishi, Akash.
You are in the group, right?
I am in the WhatsApp group.
But there must be Prabhakaran number.
Some Madam Mahima.
Mahima is there. I will put it 9677.
9677.
77.
Okay, I have Akash number, but whenever I call him, he is busy.
8942.
8942.
81. You just message him in WhatsApp. Then also I have posted the chat.
Thank you, sir. Thank you so much.
Okay. Okay, guys. See you all.
Yeah.
Okay. Bye.
See you next week, sir.
Yes. See you next week. Bye.